All right. How are we doing today? So, I made a lot of progress. Yeah, this is cool. This is a DJ Everyday from PEX Summer Festival number 10. And it's really, really good. Oh, let me get the YouTube comments up. I forgot. I always forget something. Oh, we'll go to Oh Bother VOD. I'm going to pop out that chat so it works over on my sidebar. More PCB design. I practically finished the flexi-pcb. It went really well, and there was a lot of very interesting things that I could have streamed were it not the weekend, and I was super hyper fixating on getting it done. That just happens to me with PCBs. It's so fascinating and fun to put together a PCB like that I end up hyper fixating on the little bits of dopamine, and I ended up just finishing the whole design. Mike is a bit quiet. I'm a bit quiet, I think. Let me turn this down a little bit. That should help boost me up a little bit in overall volume. The mic is right here. Yeah, okay. And then I am peaking. Hello. 1, 2, 3. Okay, so I'm not quite peaking there. That might be something. You can hardly hear me over the music. That's super quiet. All right, let's see here. Did this get turned down? Testing. 1, 2, 3. Okay, so that gets me into the... I must have bumped that. Possibly. Okay, so now that's way up there in the orange, and I barely kissed the red. So that should balance things out a little bit more. Turn that down a little bit. How's that sound? Is that good? I don't know why my mixes would be off, but shit happens. Need you guys to weigh in on that. Can you hear me over the music now? Better, okay. I think I bumped the Focusrite at some point when I was swapping batteries around. I turned it down too far. Okay, well that's good. And there's also, I think depending on which differential it chooses, one is quiet and the other's loud. That, or I think I plugged into Julian's channel, so that might be the other part. I gotta do like a sound mix down. What I really need to do is plug in my headphone amplifier over there, my DAC. Even though that'll alter the sound, I could still tell OBS to send the monitoring output to that headphone amplifier right there, and then that could be my master output. I could hang a pair of headphones on the rack and then listen in to my own mix and see if everything is nicely balanced out. Because I don't have an audio final mix, and you guys know me. I'm serious about audio. Like, I want to make sure that my audio is pristine and perfect. So I'm not one of these people that buys a microphone and then doesn't put a noise gate on it. And then there's all these and so the puzz and buzz are like making your speakers go like that every time they say it. Hey, what's up, chat? Let's see what's in this game. Pewter. Your speaker's like pop. And you're like, put a pop filter on that. I have all my VU meters in my second OBS so I can balance it. I should like make a couple of VU meters or something and put them up like on my Twitch TV rack block. That would be good. But you know, the VU meter on the Focusrite is just the color of the LED around the volume knob. They do a really nice job of that. So that's usually what I use, and I like to see it only sometimes go into the yellow when I get a little heated. Oh, you have NDI. Oh, God. Yeah, audio setups are always just a bundle of wires, aren't they? Virtual or physical. For me, I have all these audio devices that are plugged into the computer, so I've got every single channel of this mixer going into the computer. So I guess what I can do is I can set that mixer's headphone output on like one of the channels. I could set that to master mix, and then I'd have a master mix over there that OBS is streaming out. Because right now OBS doesn't do anything with that. But I have the what is it, the AIO or whatever, the multi-channel output enabled, so that I can access individual channels in OBS and set the 4 inputs as stereo pairs. It's a bunch of crap. It feels like going all digital would actually be much less hassle in some way, but then again, you can't move your signature sound. And if you were to, for instance, like, you know, I kept it open to this. I'm sure it's never going to happen, but like if I go to somebody's house and I want to stream like somebody, I fly across the country to somebody in California or another country, and I sit down at their setup and I plug into their microphone, my voice is going to sound different. And if I want to keep that signature bother sound, I would need to bring with me a device. I'm not going to bring software to load up into their computer and break it. I don't know. It's a whole thing. Some of this stuff organized. And out of the way, I need to start up Fusion 360 because we're going to be using that today. Yeah, I had one of these nights. It got really dry out around here. Like, it's really, really dry. And so I was coughing. And at night, I was watching a TV show, took a big sip of water and some other stuff, and I was going to swallow when my cough reflex went up to 10.5. And with my cough reflex up at 10.5 and a mouthful of water, trying to swallow at the time, I ended up like basically puking kind of and just coughing, and oh, it was terrible. So I'm a mess today. I am a mess today. Utter nonsense, the human body. Can't eat and breathe at the same time. You know, not built for it. Fusion. Autodesk Fusion. One of these days I'm going to take more than a month off, and I'm going to break down my whole setup, clean up everything, get all the parts away, and then build it all up from nothing. And reproduce everything that I can. I would love to move to Linux so that everything can work, and so it's not monitoring me. But this program right here is Windows, so there we are. This would be the biggest piece of software that I use, and it is not on Linux, which is the only one. The OBS has a Linux branch, right? Pretty sure it does. And literally everything else that I do could be done on the Penguin machine. So I could customize the desktop, make it good for streaming. I could do all kinds of wonderful things with Windows and sizing. And then, yeah, I would just fully be unmonitored and broken away from Windows. Because games work great on Linux. As long as we have, well, most games work great on Linux. I'm sure there's still a couple holdouts, but... Do that. Yeah, like I tried Voicemeeter. Hey, what's up, Incredimike? I tried the banana root, Voicemeeter banana, and it just complicated things. So the virtual audio cables, while useful, are a little crazy, and I still have all that stuff installed in here. Voicemeeter is a really good setup. Yeah, once it's all set up, and then you don't want to touch anything. But the price is right. I mean, it's free, so allows you to do your multi-channels and all that fun stuff. And then I guess Ear Trumpet for Windows lets you use the multiple sound channels for each application. You have heat. Good. I'm very glad to hear. Oh, the power. You were without power. Oh my God. In this economy, you have power? Stream projects, there we go. Code QMK takeover. I think this PCB is done. I think I'm finished. Your trumpet is nice, but you can't move some programs between channels. Oh my God, I hate limitations like that. That's really annoying. Wait, why didn't this one turn on? Hold on, wait a sec. Go to spring arm. Oh yeah, there we go. Okay, it's still working. Bonk. Yeah, I did the rudimentary cutout of the flexible PCB to kind of get an idea of where everything was, and the important parts line up. All of these pins line up really well. I'll have to put sticky tape, like foam tape, on certain areas to kind of hold things. Really? My summer car and system sounds are locked to a default channel. But I guess you want... No, you kind of want that on independence, don't you? 48.7 degrees in my living room currently. What's it in here? What is the temperature? 71. That's kind of cold for here. I'm actually, I got goosebumps. We'll do a quick conversion on that. 71C to F. It's 159 degrees Fahrenheit. 21. How is it so warm where you are? Jeez. That's like a sauna. I wouldn't be able to survive there. Between 71 and 73 degrees, if I'm outside of those, I'm uncomfortable. It's freezing out here. I've been able to use my super duper coat, my dock worker level coat. It's Helly Hansen, I think, is who makes that. So the keyboard, I got the schematic down. I did row and column swaps, though. I had to do row and column swaps in order to get all of the pins. And actually, I rearranged some of the functions that are coming out of the PicoPi. I rearranged some of these switchers so that it would go through properly given the complexity of the schematic. And also, I'm in insulated pants and a hoodie. That's like baking to death. I can't believe that. Oh, I mean 48F. Okay, yeah, oh, that makes more sense. I should have realized that. Sorry, my brain don't work no good. I didn't sleep well. The route multi-trace thing is really, really useful for stuff like this. Really useful. Because you can just do all of these bends inherently. And actually in the future, instead of using the curved, just simply the curved traces, I want to be using these. The curved, smooth curved traces or whatever they, I don't know what they call them, but these make for much more flowy trace layouts. So I want it to flow, not crash. Because like these are a little awkward. These sort of tight bends, corners like this. I could redo that, probably get that together, but it's a big hassle to delete all the traces and do them up again. Oh, let's also open up the one that we're actually going to work on the. We are going to work on the mixer. The mixer is in a much more fledgling stage, although it's getting to the point where we can start routing traces, which will make my stream look very interesting. I can see my breath for a little bit. Oh, God. You run a humidifier and a heater. I'm glad you got power back. Yeah, you got to be careful the pipes don't freeze at that temperature indoors. We have a couple pipes that are sort of near the edge of the house in an insulated bathroom. 69 plus 1. Huh? You just wanted to type 69. Julian's absurd mixture. There we go. And we want overall file. Yep. The water's already frozen anyway. But you gotta burst pipes? That's terrible. Yeah, you gotta leave the tap dripping so there's a little bit of motion in the water. And hopefully then it doesn't freeze. Doesn't stop it, that just keeps it from wrecking your pipes. Oh, because it can squeeze out the excess water? Yeah, the board, I went super duper ADHD mode and I hyper focused on it and I got pretty much the whole board done. It's my first flexible PCB, so I mean, I guess I should probably just bite the bullet and order it, do a design rule check, and you know, I already put the date on it. I put the 5th because that's when I finished all this stuff. And I figured out what all the JLC parameters are for board spacing. I put in all the design rule requirements that I could sort of figure out. Some of them are a little bit cryptic. But as far as I know, this is a pretty realized piece. Hold on, I'm gonna burp. Pretty realized PCB. I felt like I've had to sneeze all morning. Oh, here it comes. No, I lost it. I keep losing it. I'm keeping just about to sneeze, and then it goes away. Believe me, I looked at the sun until I saw nothing, and that didn't do it either. Just send it. There's going to be one debilitating mistake on the board, though. I hate how my social stream blade doesn't tell me whose emote that is. Plaid Amanda burp. Everybody's got their burp emotes. I need to do an emote day. That'll happen at one point. I'm sorry. I've been negligent of my streamer duties in order to update the look and feel of the stream. I need to do this stuff. You know, I need to make it a little bit more diegetic. And then I need to work on emotes, making new emotes. I've been working on work because we do actual work here. I printed this with the other printer. The brother printer, we're going to have to spend a day on. Something is weird with that brother printer. And when I get the ink wells sorted out with my 2 sets, I'm instead of doing, yeah, and I always need to work on BTS. Instead of doing like a set of reservoirs and then 2 sets of circuit boards, which would be a perfectly valid way to do that. I could just tape the circuit boards to the cartridges so that I know that when it's time to swap out inkwell, I just flip the card and tape the other one on, and then that all goes back in. I got 2 sets of cartridges because I would like 1 set to be ultraviolet, and so when we do that, we'll actually be able to like put together whatchamacallit, chewy, chocolatey, crunchy Hershey's, whatchamacallit. We'll be able to do a linear bed. Right now what's going on is it's yeeting the paper into the back of the thing and it blows it up. Clipped by Callous Raven. That looks like what I was just looking at. What's going on? Here it comes. What? Wait, what did I say? Did I just say that a minute ago? I did. I don't even remember what the joke was. I liked whatchamacallit as a kid. That ad is just like, just burnt into my brain. It's been branded into my mind. I think I've had them on a couple occasions, but it's an okay candy bar. So this is not going to have any kind of a stiffener on it. If I had the provisions to do a stiffener, it probably would be on all of the board except for around these cutouts. And then this would be a thin and very stiff board. What we're going to end up doing, though, is putting double-sided foam tape underneath it. And so I may need to put a couple pads around these guys just to kind of hold things above where it's supposed to be. And then I, of course, need to bend all of the things so that they will meet up with the pins of the ICs. But all of my very careful measuring has seemed to pay off. Seems to have paid off. There we go. Seems as to have of paying off. And these are a little bit flexible too. They can go right and left just a tiny bit. So they should be able to line up with all the pins down there. And then solder bridges over 0.2 millimeter. I'm reluctant to cut the front on discovering that the ground plane is right behind these. It's possible that I'll need to cut this front little piece off so I can do proper solder bridges, and then put in like a keep out area for the bottom, yeah, the ground layer. I should probably actually do that. We should probably do that today. I'll draw a square that'll kind of push it out. Also, one thing I discovered is that on the milling layer, if you copy the milling layer line that has 0 millimeters to it, and you paste it on the top keep out and the bottom keep out layer, then the software interprets your board edge and or keep out edge to solder mask distance. So I was able to get this distance like it was a board edge, because it is, because it's on a mill layer, by taking that mill line and putting it somewhere else. So there would probably be an infill with that much distance on it too if there were still board here. It's all about knowing how your numbers are going to get interpreted. One thing that really annoyed me is that I can't move this board edge horizontally. When I select it and I move it with the mouse, it jiggles up and down, and there's no Control-Shift-Alt function to lock it into linearity. So I can't really move it all that much unless I do like calculations. Yeah, if I add a layer, draw the outline, and then I need to make a note of it. But the problem, okay, so the other thing is with stiffeners, that means you have to be careful when soldering because you've got literal plastic sitting under your board. So I'm not going to do stiffeners on this one. And if I feel the need in the future to do it, then we can explore that. But this is my first flexi-PCB, so I just want to get the PCB and figure it out. Could Captain Tape solve the day? It's already Captain Tape. It's kind of already Captain Tape. Yeah, because I'll just be putting foam tape under this. It just means that it can get really damaged if I take it off of the like if I ever have to take it off of this, which I don't think I will. And then the final thing that I'm worried about is these placements. And I looked at them versus the printout, but I didn't do a very good job of cutting them out. I tried to use a drill bit to open them up circularly, and that didn't really work. So I just cut a window on that one. This one I kind of cut around, but it's not that even. And so if you look at the test point that it's supposed to interface with, TP6, and I get this thing lined up, house music all night long. I have to be careful not to move it. Oh, is it backwards? It's backwards. If I line this up very carefully. The two test points are kind of there, and that is TP6. So somebody's off by a little bit, just a little bit. But I don't think it'll matter because there'll be a little bit of space in that. I don't have one of those. Yeah, I think a friend of mine had one of those at one point because they kept having to add loops to their belts because all the people I know are thin for some reason. I'm the only one that struggles with being fucking hugely overweight. But anyway, so he had one of those leather belt punches, and I could really use it. I have a set of hole punches. They start much larger than that hole. So yeah, what let's see here. Is there a cheap tool that I can get that would do that? I don't really want to buy a cheap tool though. All right, actually I'm gonna open this over here first. I've been ordering a lot of stuff, so there's weird things in the... Oh, no, there's nothing weird in the timeline, except for tassels. They're little tassels. Why are there tassels? Somebody doing a dance? An awl is a little small. A screwdriver, what it's going to do is instead of cutting it, it just punches through, and then it leaves a bunch of crap on the underside. That's why I want to get like an actual punch. Like one that actually goes small. I don't think I trust $12. Although, revolving leather punch. I have that hammer. I need one that like starts at the micro sizes. That's promising. I guess they're all meant for leather, so they're pretty large loops. What if we put micro in the title? It changed nothing. Wait, no. That might be the one. These are not hole punches. These are pin tools. Micro punch. No, see, I'm looking for a hole punch, so I needed to actually make a hole. Oh, see, you can buy it like that. I see. I guess the leather ones are all I got. And that does go pretty small. That's probably much larger than the Via. I mean, they're not that, you know, they don't break it out into pins, but they are available on the top. So if I have enough struggles with those, I guess I could run from these two lines here and from the boot select button, I could run wires out. But I wanted to avoid at all costs running any wires. I could also unsolder the USB plug, but I don't have pickups for those anywhere but on the underside, because those are supposed to get to the test points. I think they're close enough, though. Tweezer look thing? I'll give you a punch. You mean the punchy guys, those the pink handled ones. And then this is the leather hole punch. But these, I don't think these get small enough. It's something like this that I would want. 0.5 millimeter to 3.5. Actually, 3.5, 0.35 is where the vias are. I could make the vias larger, but I don't want to accidentally short to the pad next to it. They're to the left on the top. No, JLC will make those holes. This is for my own testing of the dimensions of the board, because I'm running off of their files and I've got a lot of different. So third from the left is there, or this is what you're talking about. These are $5. These are what size? They're big. These are scrapbooking. 1/4 and 1/8 inch. This one goes half a millimeter to 5. This one goes 0.5 millimeter to 3.5. And it's only $10. Maybe I should get that for future endeavors. Use burn the subs to burn a hole. That would actually work. That would do it perfectly. And I could have it cut out the board edge too. Yeah, I'm believe me, I've been streaming for many years now. I don't want to admit how many years. I think 2016, 2015 is when I started. So I do know what's going on in my production. I don't know audio though. I need to get like an overall master monitor audio channel out to my mixer. It's something that I haven't had for a long time, and possibly why the mix is a little hinky today, because I turned my mic up because people said they couldn't really hear me at the beginning, and it looked like I wasn't quite getting to where I wanted to go. I'm peaking a little bit if I'm super loud sudden sound, but how big of a hole do you need? These are 0.12 of a millimeter, I believe, and then the surrounding pad, I believe, is 0.35. 0.35 might be the hole though. Yeah, 0.12 is the internal via layer to layer. Either way, very small. This would be much larger. But what I could do is, if I need to know where a via is, I could use the smallest punch, line it up over that circle, punch it, and then just look at the center. And what also I think what I can do is in the Fusion 360 output, I think I could tell it to put a big cross on the hole. So I would have a means by which to ascertain where the center of the hole is after I cut out all the stuff that would be inked. A normal inkjet printer is perfect for figuring out what the dimensions of your board are, and if you've designed everything properly. You do a little printout, you can overlay your parts on top of it. This thing got a little curvy because I only put tape on one layer. If I put tape on the 2 layers, maybe that would give me a better idea, but it also let me bend around these little cutouts that I have. It's literally the same footprint that Sonex wants on its data sheet. It's just we've been able to move our solder bridge pins back by virtue of bending the cable. So that's in line. This is in line. It's all in line. I could make sure I've made sure that everything is perfectly in place. Well, that seems to be in a weird spot, probably because I didn't bend this down enough. Yeah. See how that just kind of sits on top of the ICs perfectly. Oh, it's all right. Good to see you here. Good to get a an idea. Stencil? No, this is okay. So what's supposed to be going on here is I have printed directly from Fusion 360. And this is, technically this isn't a sponsored stream, although we are going to use Fusion the whole day today. I printed out the PCB on an inkjet printer, and the inkjet printer knows all of its distances, so it's able to basically cut a virtual representation of our circuit board out. And in fact, if you really wanted to, you could etch your own circuit board by using laser printer, it's a laser printer transfer, but still, it does it really, really well. We're going to make this out of flexi-pcb. So the best representation of flexi-pcb is just to put a bunch of Kapton tape on your paper. And so what I'm doing is we're removing the chips, and I am soldering in something to connect my circuit board to the pads of the chips, because we've fully reverse engineered this board. We know where the columns and the rows come in, we know where the LEDs come in, and so I've put those into parts. The parts I designed to be exactly like what's called for in the datasheet, what pads they want on your on your PCB in the datasheet. And so if I print that and then I give the flexi-PCB a little runway to flex with, what that does is that moves the pad back, and so it can partially overlap these pins, and I can come in with a big stinking soldering iron and I can short them out and do little solder bridges that will connect our ICs to my PCB. But what flexi-PCB is they take something akin to Kapton tape, they take polyamide, and they do the same thing that they do with circuit boards, where they deposit copper onto the polyamide, and then, you know, in a design, etch away or add in a design of your choice, and that makes it so that the copper can flex a little bit, and that's used in a lot of different products for instead of wiring harnesses. It's a really good way to get a lot of little tiny things akin to wires from place to place. What we're using it for is its innate ability to bend down and solder onto something, so I can take over this PCB. And then in order to make sure that my stuff is in the right place, I think I do need to get a set of these punches. So I'm going to buy this one. I'm going to buy the 10-piece leather hole cut pinch thing that starts at 0.5 millimeter. I think that's the best I can do. Poking it with a screwdriver and stuff like that doesn't really work, because we're talking about putting two things together and then looking through one side to see if I'm aligned properly. So I think printing it a little better with a cross around the holes, and then cutting out a small hole that's, you know, larger than the via, but I can still ascertain whether or not I'm lined up on those test points. It's something like a giant ribbon cable, but you can actually put parts on that. When does it say total is $0? Do we get like Amazon credit or something? Delivery overnight. No, I'm not doing that. No, I'll just get here tomorrow. Technically, that's overnight. All right, well, now I have the proper tool to do that if I really feel like it. What I did originally is I tried to see what I really needed to do. I don't really need the leather punches. I don't really need the leather punches. Because what I should have is, wherever there's a hole in the board, there should be a big cross that'll give you the X and the Y centers. And so then I could cut something out like this big window here, and I would have lines that go beyond it that tell me where it is. It's something I've done with 3D designs for physical stuff, and I'd have to figure out how to do that with the circuit boards, but it's all in the program. It's just a matter of knowing the process. But yeah, the whole point of this is to line these guys up, make sure that everything's okay. So good progress being made on this. I mean, I put a lot of work this weekend into getting all this stuff together and testing it. Oop. Could probably put a little double-sided tape on that. I don't need to get to these pins. So, and then actually this whole edge of the board, this whole side of the board here, I'm not really using. Using a little bit of it. I mean, that's the whole thing. That's why we work off of all these dimensions and we sweat the small stuff. The amount of precision that exists in electrical engineering is insane. If you're a mechanical engineer and you kind of know a little bit about mechanical engineering, you like moving over to doing PCBs is jarring. You're like, what's my tolerance here? And we're like, tolerance? There's no tolerance. Zero. It's a 0.0001 of a millimeter tolerance. What are you talking about? Soldering onto it's going to be a little sketchy. Nah, it'll be fine because you just put it down on a flat surface like this. And I can just go pin by pin and solder it. As long as it's on a flat surface. Got to make sure that you don't, like, you know, wrinkle it when you're soldering. That'll create a huge rigid thing here. This will be a little bit flexible, although I'll have to do some small soldering to get those parts in. And then getting this stuff down will be a matter of taping it in the proper position. Then these have just a little bit of wiggle in both dimensions that I can hopefully manage with tools and get soldered down, and then after that, nobody moves. Yeah, +4 to -1 mil. Mil is a monstrous measurement because it sounds like millimeter, but it's an English standard. We did 0603 on both this and the mixer circuit. I tried to keep it keep it a little bit friendly in terms of soldering things together. The only thing this board is missing is maybe a couple capacitors. I could put a couple capacitors on the input. And then what they suggest is in large areas where there will be copper and no components, they suggest that you put a hatching on there, which is where your ground plane is just a bunch of crisscrossing lines. I couldn't find a way to make the hatching go at 45-degree angles on this, so I'm just going to do out with the hatching and just make it solid copper. There might be blemishes on it because the process, they say it tends to trap air bubbles when you have a big copper sheet. This might not even count as a big copper sheet, though. JLPCB's flex hole size tolerance is 0.08 of a millimeter. Minimum hole size is 0.15. Yeah, these are what? These are... it doesn't give me the parts size. This one over here is 0.35. Okay, so these are 0.3. These are going to be something like 0.5. And it is. Yeah, it is. I just quoted the wrong number before. 0.12, I think, is the spacing between traces. That might be a little close. No, I think it's fine. You also have to make sure that you don't have parallel lines on the flexi-PCB. So the fact that this ground plane here is in parallel to the trace is a little sketch. I'm gonna try it. If there's something wrong with it, I can always move it around to do things a little bit differently. But like, for instance, here, I wouldn't want to overlap these by having them on 2 layers, because then it's a little bit sketchy for them to do all the cutouts and stuff. But I think I did good. I think I did all the right stuff. This one is overlapped, so I think it's okay. I embiggenated all of my primary voltage lines leading up to the micro. The Pico Pi has its own capacitors, so it should be okay. Yeah, I don't know what you're worried about. These are well over spec. Doot, doot, doot. Okay, my stomach is a little weird. I think I'll be okay, though. I had a poke bowl, so it's a lot of raw fish. There's been a lot of weekend designing going on. I had a quiet weekend when it snowed like hell, so we were able to get a lot done. Does it have an RGB LED to make it go faster? I debated about this. No, and I guess if I really wanted to, if I kept that outcropping to go over to the, whatchamacallit, the chewy, chocolatey, crunchy Hershey's, to go all the way over to, what do you call it? The, dip switch. There we go. To go all the way over to the dip switch and go to that opening in the back of the keyboard, I could probably have put an RGB LED on it. These Code 10 keyless keyboards are monochrome. They have one singular LED on all this stuff, and they're wired for that too. I think Code has RGB. I think they've figured that out by now, but the ones that I have are from like 2020, so they have a singular 3mm LED, which I think you can get, even these 3mm LEDs you can get in WS2812, but these LEDs are wired up in two banks. It's going to be a solder bridge. I mean, if you look at the size of these things, it's not unreasonable for it to bridge over the solder. So without this chip here, this will bend down and lay down on top of the pad when the chip is removed, and that I can solder bridge over. There's just a little solder bridge over that, and it'll make the connection. I don't think you understand the scale here. This is my finger. This is my fingerprint. This is very tough to solder. I would have to use some kind of magnet wire to do that. No little pieces of wire. We're not doing that. It's just solder bridges. That's what they do for the LED strips, so it'll be fine. Hey, Bothan, what's up? Yeah, it's easily solder bridged. I'll just have to maybe keep the ground out a little bit on this right here. If I keep the ground out of it, then I can cut it with a blade and get the copper right up to the edge, and that'll help me solder it down. I'll just do this right now while we're starting the stream. So if we go to B keep out, bees! Stencil top, stencil bottom, finish top, finish bottom, glue, test, component exclude, restrict. I think maybe it's restrict that I want. And then we just do a polygon. And we'll go for a square. I should probably calculate it instead of this way that I'm doing right now. That's not supposed to have a signal. It's supposed to be keep out. Wait a minute. Whoa, what did it do there? No, that's the wrong thing. Wrong thing. Look, man. The what is it? Where's the image? Like, they're used all the time for stuff like this. It's gonna be fine. Where you just overlap it and then you solder bridge it. Yeah, just like that. Just a big old blob of solder over the top. It's not an uncommon thing. It will be easy. It'll be easy. So yeah, I know that's getting a little advanced for chat, but trust me on this one. You guys are scared because you've never seen these things before, but this will work out nicely. It's a lot of weight to put on the flexi-PCB up here, but that's where I'm going to add foam tape to kind of keep it. Hold that here, and that way this stuff won't be mechanically... It won't flex. It'll never flex. And then we get a microcontroller up top where it isn't wet. Because I certainly spilled stuff on my keyboard last night. The one that we had all the wires on. I was pouring a glass of seltzer and it totally lost my grip and fell onto the desk. With bother on this one, those bridges are one of the things I'm least worried about, honestly. Yeah, and if I get enough foam tape under this, hopefully the pads on the underside of this won't make an accidental short connection to anything else. I tried to stay out of the bottom layer mostly with this thing. We can take a look at what the bottom layer looks like, or we could just render a 3D PCB, but there is a preset bottom for the layers. If I go into the layer stack and I do bottom, preset bottom, this is what the bottom looks like without mirroring, but we can always mirror our view. What was there's a button for that. M? No, let's move. There's a button for it. I forget which one it is. Flipboard, it's F. So yeah, this is what the bottom of the PCB is going to look like. There are a lot of pads on it, so I am going to have to be careful that none of this stuff can actually make contact with the board that it goes up against. But for the rest of it, I believe I've followed all the design rules. Things should turn out pretty okay. I've done all the work to get stuff onto the board. I've made a meme on the top. Preset, where's, oh, it's down here. Top's, not top silk screen. Top, flip the board, there's the top of the board. I don't know why it always puts the silkscreen layer under everything. Tented pads, I'm not sure about that. That may be one thing that I need to go over and make sure that they're the right kind of top layer pad. I'm gonna have to look at the specs for that. How I even do that. I may have to go into the layer of the solder mask layer and delete that piece of them. Yeah, because that's a cutout. But what do my vias have? Oh, it's too many layers. Yeah, I may have to go through and delete it. Find what layer it's on. Well, yeah, so they don't have to cut it out from the because I think what it is like an overlay. They cut it out of the FR, or not the FR4. They cut it out of the polyamide. They cut it out of the polyamide and then they put it down onto the top. So yeah, I'll have to take a look at that. Where's default? Standard. There we go. Standard doesn't give you the mess of like the drill layer and stuff like that. But yeah, I'll have to see what JLC wants, because yeah, stuff like this, having a little cutout for that is not really necessary. It doesn't save me all that much trouble, because I mean the whole thing is going to be sitting on foam tape, so it'll have like a 2-3 millimeter standoff that it's attached to, and it shouldn't be able to contact any of the through hole stuff that's poking through. I'm not sure if for normal vias, I guess those should be tented as well. So I'll have to like do a bunch of work on that. The Pico Pi is functioning without pull-ups. There were no pull-ups necessary on I2C. So I think they have it inherent to the Pico. Because I certainly didn't need them to get the I2C display to work. So let's see. There aren't resistors on the board, I don't think. It might just be internal, or maybe that's what these two are. Those are going to ground though. And the I2C is coming from these two down here. I certainly didn't do anything in my design to make that happen. I mean, maybe I'm just getting away with it. I don't know, because I don't have that on the keyboard itself. Let's double check. Smith Clay subbing for 37 months. Smith Clay, thank you so much for subbing. Thank you. Pico Pi, I2C, pull up. Internal pull-ups are 2 weak. 4.7 is a good place to start. Anything between 2 and 10, although mine seem to work just fine. The Pis have 1.8K pull-ups on the boards for the I2C lines. The Pico doesn't, so you should add something. I didn't have that experience at all. You won't need external pull-ups if the device you're connecting already has them. I don't think the screen does. Let's get a screen. One of the screens that I used. It's this one. Maybe it does, but I don't think they would go the extra mile. None of these are the right kind. I need one of the little ones. I need to keep this screen bin going. Do I have a screen in here? The display will have it. The SD 1306 units typically have them on the underside. I see. Okay, so that's probably where that came from. I basically designed this board from the working model, so you know, we had it working physically in the real world. I built up my keyboard and I've been using it for months. So generally, if you guys see me doing something weird, it works nonetheless. That's one of the big boy displays. Where's the weird display? Where's my long displays? What did I do with them? They're in some kind of a container somewhere, or they're up here on the desk. Let's see here. I thought I saw one that was kicking around up here, but I could be wrong about it. I look at it every day. I look at one of these displays every day because they're on my keyboard. And I'm gonna have to, I don't know, maybe use the 3D scanner to make a cutout for that really crappy cutout that I made in the keyboard, and 3D print something that's either so thin or tinted to work as a window for that screen. I don't have any of those displays readily available. They're probably in a bin somewhere. Nah, could've sworn I had one that I was staring at every day over here. I know there is one somewhere in my parts, one that doesn't have a backing board, but the backing board is what we're trying to look at, because that backing board likely, and I'm pretty sure this is the case, has the I2C pins on it already. All right, whatever. The pull-ups. What languages SDK do you like to work with? So I use the old school Arduino SDK, the one that barely does any context highlighting. And then I use Arduino. I really enjoy programming for the Arduino because I didn't enter this game as a programmer. I came in here as an electrical engineer who is now required to do a bunch of mechanical engineering and software engineering. So Ben Gizmo, can you let me just function on my own? It's okay. Yeah, I think that is what I have. That's what I have. LCD Wiki, is that a thing? Check this over. Yes. And actually we have the screen itself from my old glucometer that is one of these things, but without the backing board, and you can figure out how to connect to them directly. They're nice little PCBs, nice little screens, but apparently these have the pull-ups on them inherently. I wasn't too concerned about it anyway, but this is what they use in QMK. It's too bad, though, that QMK can't get other information for the computer without you having programs running. You have to have, like, specific programs if you want to have something like an audio monitor or the time and date on the little screen, because it would be kind of neat to put stuff on it. Not that it's totally necessary anyway. Yeah, this is a Born Slippy mix. Mega white thing, whatever you do, and come and see her. Drifting on Angel Boy. But yeah, this was done. Like, this board is done. I'm ready to order it. I need like another camera that just can display behind me what I'm looking at, right? And then somehow it zooms in and it shows your comment. And how it is directly adjacent to what you're talking about. I will stop responding to that comment because I've already gotten one that's natural. All right, with my mood fucking killed, let's get started then. Let's just start the stream so people can stop fucking telling me that it's starting soon. I'm gonna ban you next time you do that. Okay, so let's get the start soon out here. Overlays. No, not overlays. It's in setup. Bonk, bonk, bonk. All right. On the other keyboard, I am running QMK. And I've been running it for a couple years now, actually. That's not to say that I know anything about how it works, but... can you not see that it gets me nettled? Can you... All right, read the room. All right, so anyway, I haven't gotten a lot of sleep, so I'm not really willing to put up with you guys today. Let's get the music out of here. Where's the music? Where did I put the music? It's all the way over here. All right, lower that down and hit pause. All right, yeah, I wanted to work on circuit boards today. I was kind of going over with you guys some of the stuff that I did over the weekend, which is to finish the circuit board that we were working on before. One of the things that I was trying to do is get to the point where I'm putting traces down onto the PCB with you guys there so that you can see that part of the process. But the weekend snowstorm hit and I had nothing else to do. I get very bored during the day because I don't want to be playing games during the day. It feels like I'm wasting, you know, precious hours of my life. So what I do is I work on things. And so I was working on this circuit board over the weekend and doing all the CAD design. So we've got a whole bunch of stuff going on here that you need to just stacked layers of things that you need to look at and work on and get right. There's things that are inherent to the flexi-pcb, design rules namely. There are things that are inherent to FR4 PCBs, like the sizes and the spacings and all that stuff. But once I got that punched in, this design flowed very quickly, primarily due to the fact that I wired this up in one layer of wires on the physical circuit board. We had a flat wire wrap wires, and so that was easy to translate into traces. And one of the big assets of doing it this way is that you can use some very specific tools that Fusion has in order to do the routing. What you can do is you can route multiple, and what that'll do is it'll allow you to put like 17 different traces down all at once. One thing that kind of bugs me though is the sort of tightness of the bends of some of these. I think what I need to do next time is I need to work with the 45-degree angle bendy kind of things. These are a little bit unwieldy, but they put together kind of a smooth looking circuit. So maybe we'll use those on the mixer board. Oh, your PCBs, some of my favorite streams. Oh, thank you. Thank you. Hey, Silly, what's going on? works good enough. Well, okay, so one of the things that we didn't think about was tenting of these vias, so I'm probably gonna have to go back in through the design and specifically on whatever layer it is. It would be this, not stencil top, but it would be something like solder mask top. I have to go through and delete these because they're all not tinted. Oh no, it doesn't have any, we're not dealing with RF frequencies. This is rather high frequency, right? We're not dealing with like low frequency audio or analog, in which case it really wouldn't matter. But in our case, we're dealing with digital signals flipping. These are analog chips. These things are slow as all hell. So we're not really dealing with the considerations of RF going through our bends. These could be right angle bends. They would be totally fine, except for maybe, I'm not sure what the flexi-pcb process is like. There's some added weirdnesses. So like, what is it? Solvent traps or something that people used to worry about when sending a board to a house, where you would have a right angle and that would become a trap for a little bubble of solvent, and that could end up ruining your board. The process for doing FR4 PCBs is so much different now that you don't need to worry about. The endoscopy went really well. Thank you for that update. No, I'm glad it went well. I'm glad it went well. I vaguely knew that you had something coming up medically. That's good to hear in the middle of my explanation that your butt's okay. Okay, so so we're not too worried about like bends. We're not quite getting up to RF frequencies. We are at higher frequencies, but they're nowhere, they don't like hold a candle to RF. Things I look for when I'm doing a PCB like this in the ground plane fill are sort of these long areas of ground fill. That is an antenna. And it's an unfortunate antenna that I have sitting on the end of this piece of ground right here. And it's next to stuff that, what is that, column 2, column 1? Or no, that's, oh, those are the returns from the column sensing. So as we go through and put 3 volts on the rows, we go through all the columns and we get a sense, so we get a digital input from the columns. Those I want to be sort of a little bit isolated, but it's not totally high priority because again, we are not anywhere near RF frequencies, so. Can we all watch it? They didn't offer, but I was wondering if I could get a copy. You guys want to see my ass again? From the inside? So here I couldn't fit a via, but there was an outcropping. That I would consider like a bit of an antenna. I think it'll be okay, but it would be a really good opportunity to bridge these 2 ground planes across the 5-volt thing. Group stream it on Discord. Oh, don't make me make new rules. That's a rule. That's one of the rules of my Discord, is don't make me make new rules. It's a really weird one. Okay, wait a sec. This layer, I need to unview this layer. Preset standard, this would be, oh, it's not in the preset standard. Solder mask top. Getting away from these standard layer, and then the values. Who needs values? Come on. There we go. So yeah, marginally, for the most part, this is done. Just some tenting of the traces is all I really have to worry about. Still have some pics from mine. Oh God. No, I did the endoscopy. Wait, which one is down the mouth? That's, oh, yeah, that is endoscope. Yeah, I did do an endoscope. When I woke up, I told them I thought I was watching YouTube videos the whole time. I just overshared with them. And it's down the mouth. Yeah, when they put the thing on because I did one of the ones where they knock you out, and so they put the thing on my mouth, and I'm like, are you sure this is one of the mouth ones? Because they also do the other end at that place. So I was a little light on the ground vias. I was a little light on the ground vias. I kind of tried to use them sparingly because I don't know exactly what they're like on the flexi PCBs, and especially like this is a part that I'm going to flex, so I don't necessarily want to have any of them here. You need a meme for the PCB. No, I don't. I already have one. Yeah, That's all. I just want to make the person who has to check over these boards laugh. That's my feeble attempt. But other things, maybe I could figure out exactly where these holes are now that we've got kind of a semi-final design. So I'm not going to jump to order this right away. If I had, it would have already been ordered 2 days ago. I'm not going to jump on it to order it right away. What I'm going to do is I'm going to do another printout and then lay down more polyamide. Oh my God, all these terms are leaving my brain. Do I have brain damage? Probably. Last night was a little rough on me, and maybe I didn't get enough sleep, so my brain might be just kind of chugging along. Captain tape. I'm going to do another piece of paper with Captain tape over it and very carefully cut it with a syringe, and then I can do a little hole punch on these because I'm going to order these hole punches like right now. Yeah, if I really wanted this to resemble the flexi-pcb more faithfully, I could also put Captain on the back. I already posted that. Somebody else already did that. That exact joke. That's in our Discord. It's in the Discord. It's already there. Where's my hole punch? Oh, did I already order them? No, I don't think I did. Did I? I'm gonna have to open that up. Hold on. I've got so many windows open right now. Oh yeah, there it is. Wait, is that it? No, that's ink. I'm gonna close all the ink windows from the other day. We are gonna have to actually go back and I did order it. Did I order it where you guys could see it? I hope not. Going back to Amazon and opening that up in another window that you guys can't see. Orders arriving tomorrow by 10. Okay, yeah, I did do it. Hopefully you guys didn't see anything. All right, so yeah, I've got hole punches coming in the mail, so I'm just going to try that out just so I can get a final lineup. And I'll probably put a piece of double-sided tape down and then very carefully place this so it stays still and I can flip around. No, I hit it? Okay, good. Look, that's one of the things that keeps me up at night when streaming. You know, I don't want that. There's a couple people who have negotiated my address from me to send me things, which I guess I'm fine. It's, I guess, one of the perks of the job. Send me something that you want me to review, but I have to have the policy where it could end up in the garbage if you send me something that's sort of off schedule or weird or I just can't get to. This is the 2040, and it's a 2020 2040. I think they did a little revision to it. Short Lurker was worried about this, and we set the score straight. But basically, Twisted Sister messaged me immediately when these are available. Listen, guys, it takes a village. It takes a village. I am not that good at stuff. I have friends who will let me know when there are sales on stuff and things like that. Like that's the only reason I was able to get like 5 of these for $5, right? Back at the beginning of the pandemic when they were a little bit more rare. You could of course get the Raspberry Pi chip for $1, but I didn't want to have to put all the support equipment down. It is a limited amount of support equipment, but that's just more work for me when I've already bought a bunch of these Pico Pis from 2020 and I need to give them a job. So using their own 3-volt regulator, using the EEPROM that they have on there and the clock that they have on there for an extra $4 per design when I'm only going to be making 2 of these things is just fine by me. This was an exercise as a practice. Exercise. This was a practice in building a PCB, and I branched out a little bit more by making it a flexi-pcb, which allows me, of course, to interface with all the pins of the previous brain of this thing. So I can get rid of their EEPROM, I can get rid of their Sonics chip and the clock and all the accoutrement from the clock, and then I can take over its job along with the job of the RGB LEDs for numlock and caps lock, as well as the group of LEDs that turn on and off the backlight, which is over here. This thing gets the RGB LEDs because it's sort of it's like a task manager thing. This can overwrite the programming in this. I just ordered 2 2350s to play with. The computational overhead of the RP2040 is absolutely insane. I don't know what speed this thing runs at, but it and the Teensy 4 are kind of in the same category in my mind. in my mind, and my mind is, here I am, a human being on planet Earth. I am a organization of meat and chemical that has electricity in it, and I can perceive things at the speed of a neuron firing off. And that, in comparison to the digital world, is extraordinarily slow. And so the realization of what time means to me and what time means to a microcontroller, they're two totally separate things that I can't even put into comparison. Arduino stuff, I kind of get a sense for how fast it is, because it'll get overwhelmed if we do some heavy digital or RF tasks. But then you get into more modern stuff and you get to the RP20, well, you get to more modern stuff and things are so fast that you don't need to worry anymore. And then you get into the RP2040s and your TNC4s, and time is just a concept. I don't even know what that I don't know what that, we were doing like singular microsecond timings in the thing. And it was bored. So, yeah. Milk V Duo S. Huh? What's the desire for this? This is quick mechanical keyboard on a code 10 keyless, and it's a complete takeover. So I'm getting rid of the brain of this thing, and I'm moving it to the Pico Pi, which we were very successful with doing just around the time when the Pico Pi was supported by QMK. And then I made the circuit by putting a bunch of muxes that I happen to have that are kind of slow over here, and then wiring to this stuff. And I figured I could put that on a PCB. The whole purpose is that I spilled stuff on my keyboard, and spilling stuff on my keyboard put liquid down here. When liquid gets down here, not only do the buttons fail, but it kills the microcontroller. I don't know how, I don't know why, it killed the microcontroller. So it killed the microcontroller, and then I put the Pico Pi in there instead, making it more of an open source keyboard that I can do whatever I want with. I can do a little screen, I can put knobs on it. Turns out I don't want any of that, but I could if I wanted to. And so I decided to round this into a more permanent design. Now, there's no means by which to expand this design. I didn't put pads down. I guess I could always solder wires to these pads, but I didn't put pads down to expand the functionality at all. We're literally just replacing this micro with our own micro and putting it up higher where it's out of the water if I happen to spill anything on that. Yeah, last night I was pouring a bottle of seltzer water and it dropped out of my hand because the edges went soft. It didn't stay, I didn't keep it round. I crushed it a little bit, and then that went out of my hands, boom, and then seltzer splashed everywhere, and a little bit of it got into the keyboard. I was able to pop it apart, you know, towel off the corner with the control key, and it got back to working again. So the QMK with the Pico Pi works. Now the muxes that I'm using are not like, if you were to do your own, I put my keyboard in the dishwasher. Look, something about the setup that code uses is too sensitive to liquids. But if you were to do this on your own behalf, I would use a different mux. My muxes are analog muxes. They work at positive and negative 12 volts if they need to. So really, they're overkill and they're too slow. They're just translating analog voltages. A digital mux could probably go a billion times faster. We don't need it to. We've slowed it down a little bit in software and everything works out just fine. So I'm still using them. I'm not going to order new muxes for this project. So this was literally the whole crux of this project. The whole purpose behind this project was to get back into designing PCBs and kind of learn a little bit more about that again. So anyway, that's the purpose of this. That's why it's kind of a little bit eclectic. It's a bit specific to my own purposes of building a flex PCB. And I know I could probably move these lines down a little bit. I could move this in a little bit, but it's too tough. I don't know how to move linearly without using calculations. And then, you know, ultimately, if I was really hardcore about this, I could replace this entire giant board with just an RP2040. I mean, that would make the circuit a lot more local. I could just bust it out this way and instead have an RP2040 over here, just the chip. And then I would need my own voltage regulator. I could do that up the top. That's a lot of work. So I'm just pasting down the Pico Pis that I already have and then bridging to some of the less available pins, the ones that are on test points, in order to make no wires, but a full takeover of this thing without having a bunch of little wires running all over the place. And then if we get this one to work, I can then jump out and take another one of the boards, because you get 5. So I'll take another one of the boards and redo all that wire stuff that I did. It turns out it's a pretty easy takeover once you reverse engineer everything. So I know where all of my rows and columns are. I know where 5 volts is coming in. I know where the backlight is controlled from. I know where the boot button goes. So I can take those, wire them into my own muxes, because the RP2040 happens to not have enough pins. I don't know how many pins. I don't know if this is every pin on the Pico Pi. If the RP2040 natively had enough pins for me to control the stuff I wanted to control, then it probably would have been like a no-brainer. I could have just put it right here with all the stuff on it. Let me just double check that. Let's do an RP2040 pinout. Chip itself. Get out of here. Manage consent, my ass. Wait, you said, oh, there we go. 21, 25, GPIO 29. It looks like you only have 29 GPIO. And how many am I using? For rows and columns, 8, 12, 16, wait, 8, 16, 24, 24, 25, 26. Oh, those are actually bespoke. Never mind. 24, 5, 26, 27, 28, 29, 30, 31, 32. 32 versus 39. So maybe if I use the base chip, I would actually have enough I/O to run this. If it's 36 I/O and I'm using 32, that actually might work out if I just put a 2040 IC down. Well, that's something to consider for the future. I'm going to walk into this one instead of running into the final conclusion, I guess. And this uses the RP2040s that I already bought, so there's all that involved with it too. It looks like, yeah, I would barely get away with it because I've got, what was it? 24 columns and rows. I'm not doing that. 24 columns and rows, and then I have 1, 2, 3, 4, 5, 6, 7, 8, 9 different I/O. It's not really scope creep. It's actually just whittling the design down into, because then I wouldn't need to have all these switching elements. I need to redo the software so that it didn't have these switching elements in it. But we're doing it the way that I got it to work before. So, because I did run into part of the code where I had to actually slow the processor down a little bit in order to get it to properly read the columns and rows, because these weren't getting up to the voltages they needed to get to fast enough. So if you make it all just use the microcontroller, that's well and good. But yeah, the 3050 is 4 more pins. I don't need those 4 pins. And then, well, yeah, I guess these transistors were necessary to handle the current. Oh boy. Well, whatever. It's all primed out. I've all got it ready to go. God, I've got that weird feeling from. So I told pre-stream this. I'll tell you guys this. Last night I was drinking seltzer and I took a big swig, and it's dry around here, right? It's gotten very, very dry over the past couple days. Just because of all the snow and the winter weather, and I've had just like a cough, like a background cough, and so I took a big swig of seltzer water, and just as I was swallowing, my body went, "You have to cough right now!" And I'm like, "What? Huh? What do I do?" And then I went, and then blah, like it was just like puking. So I've got that weird like nose feel from fluids getting where they shouldn't go in my body, even after sleeping. It's terrible. My nose is like hating on me right now. I need to. That's right. I need to do a check over here. In the acid and nose feel. It's great. I love it. Wouldn't trade it for anything except not that. in my design here, what I wrote down is going to differ a little bit from what's actually there. And I think one of the primary ways that it differs right now is that what I've written down has pull-ups on the transistors that it's using. So I've got 3 transistors down on the board. They don't have pull-ups on them. I don't have this on the final design, on the one that's actually soldered. So we're gonna get like a foot of snow here in Texas. I'm worried. Yeah, the Northeast is much better prepared for that. Just don't overdo it struggling. Struggle. Don't overdo struggling. You know, be okay for a little while. Brain? Hello? Brain? What are you doing? Shoveling. Snow shoveling. Heart attacks. Overexertion. You don't realize how much work you're doing while shoveling snow. Even if it is Texas and everybody's tough. Take it easy. Because people over 40 die with regularity such that the EMTs called shovels widowmakers, which is what we call the stock jack in a VW, but still, they call them widowmakers. Stay in and drink beer. Yeah, wait for it all to blow over. I almost just spilled my seltzer. If you are, shoveling, if you have to go struggle shovel, just take it easy. Take a break, let your muscles acclimate. The cold weather is going to make it so that you don't feel the fatigue as much just because you're cold, but your body's working hard to keep itself warm at the same time. So be lazy with the shoveling. Don't call me that. I'm over 40 and I'm fit. Yeah, no, seriously, it's something to be careful about, because it's like you go from total inactivity and desk work to shoveling snow like you're in the best shape of your life. It may have an effect. You got to be careful about that. My dad, he's like 70 years old and he's out here like busting his ass shoveling. I'm like, you got to stop doing that. you're gonna fucking die. Like, Jesus Christ. More worried about the power grid? Yeah, the Texas power grid is also a tough one, huh? Isn't it? You can actually buy candles. They're these candles, and what they do is when you burn the candle, it'll release oxygen, and it's sort of like an emergency oxygen candle. So you could theoretically stay alive when your power goes out. They have them in submarines and stuff. We don't even own a snow shovel. You can sweep snow. If you have a hard broom, you could use that. But once it snows and it gets a little warm with the sun, it's going to start to get hard to sweep. So, BTS, so you can melt snow from the inside. I was considering getting one of those torches, the big torches that they use in cooking, and you hook it up to a little propane tank, and you can just melt everything away. I kind of wanted to get one of those. It's basically that is the primary component of the Boring Company's quote unquote flamethrower, which a friend of mine had, and it got stolen from him. I'm very sad about that, because I would have loved to have that in person here. He says they're worth quite a bit now. But all that thing is a plastic shell that goes over one of those big torch wands. It's like a metal wand that has sort of a wider area at the front. Clearing ice off your driveway. Yeah, I need to, you know what? It only snows once every like 3 years here, but I'm going to buy one of those right now. Of course, that means I have to disassemble the barbecue when I do. Roofing torch? That sounds right. Well, I mean, they use them in cooking too. Too small. Getting there. Oh, that was one. $50. They did not used to be $50. Did that just open another window? I saw everybody over here rearrange. I ain't spending $50. Flame King propane torch. Yeah, that's a little bit much. And a backpack propane holder. How convenient. Show me the other models. There we go. You want something that's practically going to burn down your house. These are all $50. Fuck that. No, that's not worth it. I'll just shovel. It's once every couple of years. Yeah, you want the ones with the long pipes so you don't have to bend over? What's all this about? Oh, the TX-RX jumpering. I'm not doing this. I already know. I know which ones are TX and RX. I don't have to do this. All right, so the JLC manufacturing requirements I do have in the CAD program. I'm going to sit on this design until those hole punches get here. Once the hole punches get here, I'll do all of this list of checks, you know, look at all the cues and figure out if the circuit is exactly the same, check to see if I've got pull-up resistors on there, and I didn't know about that. For the most part, I think what I saw is that I just have the input resistor, and then, well, actually, were the resistors going to ground? I'm gonna have to check these over and just make sure that I've got what I think I've got. And then I can take a look at the design rules. I can get rid of the tents on the cutouts for the vias, because those can be tented over by the polyamide. I think that's what they prefer, and I have to figure out how to do that in a batch, because there's a lot of these to go through. I think if I just view the solder mask layer, like only, I can go through and delete all of the ones from these little guys. These, of course, need tents around them because I'm going to be soldering these to test pads. Same with the through-hole ones that are just going to be, these are basically functioning as pads. I did them through-hole just because it's easier to just drop this down and solder some wires to it, and then those will go to the hole in the PCB that'll get it to the screen on the other side. I'll have to find where my screen is. And then I think I'm just ready to order. I think this is just ready to order. So we'll have to do that. No other notes on this except maybe, why did you do this? Why didn't you just do it with an RP2040? That's always a consideration. RP2040, throw a clock down, throw a voltage regulator down, and that's it. I wouldn't need the muxes. But I'm going to build exactly what I had before, and maybe at a future date we can revisit this. But again, this project was not all about taking over the keyboard. It kind of is. I did want to make sure, that I use this thing, but mostly this is being done because I need to kind of refresh myself on how to design circuit boards. So I found a project that was less demanding than the mixer, but I kind of finished it to the point where, and again, this is something that you guys should do if you're given the luxury of doing this. This should be standard part of the process. Unfortunately, at a workplace, it's not, because they feel that if you're not working on something, you are wasting an opportunity. So you will have to go from start to finish on your circuit board and do all the checking over while you're exhausted of the design. I think that that is a failing. I think what needs to be part of the process is you put the design away and you work on something else a little bit. Because what that does is it lets you just go, okay, we're done with that for a bit. And then you can come in fresh and you suddenly start realizing that you're missing a bunch of stuff. There were some examples of that this morning, well, at the beginning of stream, when Ben Gizmo was doing his usual poke bother until his patience is gone routine, which he does, and he's routinely right about everything that he talks about, but it grates on me every time, and I apologize that I'm like that, but that's just how I am. But yeah, so there were some things that I need to look at again on that board. I am going to not think about it for a little bit, but I have already ramped up on, you know, what I need to do, what I need to think about, how I need to think in order to put together a PCB. A lot of it is just visual. A lot of it is just visual. I mean, you can sit there and sweat the small stuff all day. Do I need a VIA here? I could actually rearrange this and do that this way, and then I'll have this row on this column, and then this does, you know, or you could just make it look nice. Especially at the frequencies that we're running at. For a moment, I thought Red Dog Camp won't survive the winter. That's my prediction. No, you'll be fine. You'll be fine. A foot of snow is not that bad. Just everybody's going to buy milk and bread and toilet paper, and I think that's related to the sort of gastric distress that's caused by an excessive amount of French toast. Because everybody's stuck inside in the morning, and they go, well, good thing I bought all that bread and milk. What do I do with it? Oh, I'll make French toast. And then your tummy rumbles and you have to spend an extended stay in the bathroom. Milk and bread is not that important. I mean, the toilet paper, sure, but just as long as you do like a grocery shopping sometime ahead of it, like a couple days, you'll be fine. Well, depending on what Texas is like, because around here, I guess around here we've got all the plowing set up already. So it's like you spend a day indoors and then everything is totally fine again. No French toast egg allergy. Probably a lot of undiagnosed egg allergies out there. You need at least 9 years worth of toilet paper for 2 days of snow. Yeah, the thing is, like, they may be buried for a week because it's Texas. That may be a possibility, depending on what the weather does to the snow as well. And you're also going to get all these people in giant trucks careening down the road because they don't know how to drive in snow. So very little plow or salt. Yeah. Last year we got 7.5 feet. They're not, yeah, I was with a neighbor this morning. I was comparing New Hampshire to Norway in terms of like getting completely buried in snow. But you guys have infrastructure for it. So yeah, just buy enough beer and buy enough stuff to eat. Jar of peanut butter. I don't know. You'll be fine. All right. So anyway, yeah, just hibernate. I can survive without cake. If you can call that surviving. If you can call that surviving. So here's the mixer design. The mixer design is doing a lot. And I actually discovered that if you try to make this into 2 pages, it'll delete all of the hardware on the board and put it all back in. So we're kind of stuck with this one being a sort of hybrid, more than 1 page schematic, which is a little unfortunate. But, you know, I've made, except for doing gate swaps and stuff, I've made all of my choices in terms of hardware. Outside is your freezer. Yeah, let's fucking throw the meat outside. It's not like that here because the snow sticks around for a couple days. We get like 3 feet of snow. Not 3 feet. We get like a foot of snow, and then it only stays on the grass all year because they salt and plow and do all that stuff. But yeah, man, the winters in New Hampshire. I was telling my neighbor about how I had to pinch an ice cube all night because we were using the wood stove, of course, because it's awesome. And I wanted to look at the fire. So as a little kid, I went and I tried to lift the door and open it. It is also made out of iron like the rest of the stove and is in direct contact with the fire. It was very, very hot, and I very much burned my index and thumb. Oh, Silly has a picture of the snow in Norway. I don't know if the comparison is 1-to-1 because I think New Hampshire is probably a little bit more mild than Norway. Look at that. That is ridiculous. What they do in Newfoundland, and probably here too, in regular Finland, is you just open the door and you put the beers in the snow and close the door. And so it's between the door, which is going to be kind of warm, and the snow, which is ice temperature. And so it'll keep your beers at a good temp. That's definitely too much snow. Yeah, when it gets over your knees, basically what I want from the snow is I want it to be higher than the corgi. Because I posted that video in the Discord of Willow absolutely loving the snow. She loves it. It's nice looking. Yeah, and you can use a snowmobile. You can finally use a snowmobile to get your groceries. I like the snow. I like the snow, but I guess I'm less inconvenienced by it than other people. Because if I get snowed in, I'll just stream and design a circuit board. So Julian's absurd volume knob. We have everything that I've got on the perforated prototyping board down onto this circuit. The only thing that remains would be swapping the different gates so that I have a little bit more of a sensical circuit. But there were a lot of things that we had to kind of consider when putting all this stuff down. And one of the big considerations is that Julian wants this to fit into 2 HP. This is 4 HP. 2 HP is half of this size. This whole mixer, this whole circuit with all these components has to fit in a very small footprint. So I actually found an op amp that fits into a tiny, tiny little chip. Tiny, tiny little thing here. And built the rest of the mixer with that to the degree where we could test it. One of the things I didn't do was the hardcore engineering tests, like hitting this thing to figure out what its frequency responses are and stuff. I don't know much about that stuff. I'm an amateur. I'm just kind of putting this thing together. But we did find a way to do the complicated controls that Julian requested. And that is when you turn one of these knobs up and down, you are altering the volume of a pair of right and left inputs. So it's 2 right and left inputs. The rights and the lefts are mixed together and put into a stereo jack that has its own independent volume control. So you get your mix done, and then you get your output done. And apparently that's very useful for Julian and not all that common to find. So I would say you suddenly discover how light your car is when it starts careening around in the snow. Because when they plow that shit, they keep a nice layer of smooth snow on the bottom of the plowing that your car loves to grip. It loves to grip. It loves gripping that stuff. And then you have people who don't know that they're supposed to be driving in the snow. And snow driving is unique. Everything is slow. You kind of slow your brain down. Everybody slows down, presumably, because when you start to skid, you very slowly correct it, and you can kind of get stuff going. If you've got a front-wheel drive car, you add power. If you've got a rear-wheel drive car, you panic and go into the side of the road. But it's just all about knowing the dynamics of your car and how to manage it, and possibly putting cinder blocks in the rear. I love snow driving. My friends and I, before they all moved away, would get together at parking lots and spin around in the snow in our cars. Yeah, I've had snow driving where I've been sitting in the car, wheels all the way to the right, and I'm looking ahead of me, and what I'm seeing is the curb going in parallel to my car. So I'm looking forward, and the curb is just going. I'm like, oh, I was literally traveling like that, and it was around a turn too, so it was just like. And then what I discovered on one of the things, I was in an old Volvo. It's a Volvo 164. And it was a Volvo 164, which means they took everything ahead of the firewall on a Volvo 240, and they made it English-sized bolts, and they made it luxury looking, and they put an inline, I believe, 5 iron block under the hood. So I had all this weight in the front. Rear wheels were trying to navigate the car. I was going down like a heavy hill. It was one of these hills that has whatever they're called, where it like goes down and then flattens and then goes down and then flattens. I did not want to break my car. I didn't want to crash my car. But a plow had been kind enough that there was a car stopped on my side of the road, and they plowed around the car and then back into my lane. So I'm going down towards this traffic light where people may go across if there happens to be a car there. Not a lot of cars because it was during a snowstorm. I'm going down this incredibly steep hill, wheels all the way to the right. If I hold the brake, if I push the brake, the car goes to the left. If I let go of the brake, the car goes to the right. And so I had to use the brake pedal to wiggle my way down without crashing on this swoopty road. I could only moderate speed by the frequency in which I wiggled. So I had this completely nonlinear control to get my car down this massive hill. And then I ended up, because it's like a big valley to get home at the time. And so on the other side of the valley, there was also one of these hills that's kind of tapered. I made it up to the last one, and then I had to ditch the car and walk home. It turns out in foot-deep snow, the walk home is a lot longer than you anticipate. I probably should have tried to get the car moving, but I just gave up. I came back to it the next day and dug it out and got it home. Yeah, it was torque driving. Torque wasn't a thing then. That was the early 2000s that I was doing that. Speaking of lifted, yeah, these people that don't know how to drive in the snow, they don't know that you really need to slow down, because you're not going to know if you're going to get enough grip to stop. You got to be really careful out there. Careening all over the road back in 2021 during the first big snow that almost killed the Texas grid. I vaguely remember that. Yeah, there was a 133 car pileup, killing 6 people in Fort Worth in an express lane. I saw the videos of that. People just don't know. Meant to keep the shiny side up is what the ambulance man told me when I had a crash in the ice in 2006. Oh my God. You're like, I don't take care of the car. It's not shiny. What's that? What are we saying? Hold on. Driving a few years ago when I came out for black ice. That's the worst. I've run into that in the city before, trying to stop behind a car, and I pop into the front just because all of the snow melts and then everything goes to the drainage on the edges, and then that freezes. And city driving, there are no rules in certain parts of the city, and so you're trying to go around people on sort of the very edges of the road, and that's where all the ice is. So yeah, I ended up booping a car by accident. Zero grip. That's when I was off road. You were fine, but the car was totaled. Well, that's a good car then. Yeah, any of my car issues, they were like, did the airbag deploy? And I'm like, this car predates airbags. done the same thing when I went over a hill, saw a line of deer crossing by the street. My, is that great uncle? Or god uncle or something like that. I don't know what the relation is. My grandfather's first marriage, his son, was going down a hill in his BMW SUV, and there was a moose in front of him. And so he did that classic moose test where you have that huge amount of mass and the spindly little legs just kind of whoop. The car pretty much saved his life that day. It also kind of got him into that mess, but still. It's because the headlights, when you're going down a hill, were coming up like that. And so it was like nothing, 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 legs, 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 moose! Take a stereo signal, inverse the phase on one channel, put it into a mono signal, and then reverse that. Stereo to mono, able to be translated into stereo again. I don't think so. That's a weird one, and you could definitely test that with this stuff. The stuff that I'm using to do this, in order to do the voltage-controlled volume, I'm using a chip that's called V2164. There's a couple chips like it. They're used in modular synthesizers because it's easy to take that voltage and turn it into a current, and then that current, voltage into current, and then the current can be mixed around. It's just how they do it. And then you have a voltage input signal in order to control the mix of that. You can play around with inverting and reverting your audio signal. I mean, you could do that with just regular old amplifiers too. You could take some TL072s and you can set them up in unity gain amplifiers and start putting stuff into stuff and see what you get on the outside. When you're going to hit an animal, speed up, don't slow down. Who says that? Is that somebody who doesn't want you alive? Like, I have slid into a barrier while exiting a highway because of black ice. I have hit a barrier going into an exit, entering the highway while I wasn't in the car and it was being towed and we didn't put the chains on it properly. That was my 944, unfortunately. Those things are worth a lot now, aren't they? I should have kept that car. Probably would have spent an inordinate amount of money storing it, unfortunately, the 944. I had a burgundy 944. I love that car. I really did. It's just I got bogged down in putting a Chevy motor into it. It was one that some kid broke at a Delaware community college. Some kid was... I don't think the kid was driving on the highway like he said, and it suddenly stopped working. Although that is a thing that can happen with the 944 because it has a timing belt and it's an interference engine. And belts wear down a lot more than chains. And in an interference engine, if you don't have that timing going on, your cylinder head can share space with your valves and it just grenades the engine, which is exactly what I was looking for, because then you can put a Chevy motor in there. You can put an LS 1, 2, 3, 4, 5 in that car, and it becomes an incredible two-seater, 2+2. So that's what I was working on. The car that I found had a huge dent in the rear fender and the motor was grenaded. So my theory is that this kid was I own a Porsche, wah, sliding it around in a parking lot at the community college, and he hit a pylon, because it really did look like pylon damage to that rear fender. I have a belt valve from the original 944. If you want one. No, that project never got underway. I converted it to manual steering. I put the turbo, front brakes on the rear, and then I found other Porsche brakes that fit on the front. So I upgraded all of the tire, the wheel size, the brake size, the motor size. I was going to do everything correct. Nowadays, I realize that what I should have done is just concentrated on getting the motor in there and getting the car running. That's the most important thing about a project car, is that you get it running. Get it running. Don't do everything from the ground up. Get it running, because you're going to get bored of it. And I kind of crashed on that project and then sold it to a grassroots motorsports competition team. I never knew if it competed or not, but and then in the intervening 10 years that it's been since I had that project car, the price of a 944 shot up into the stratosphere. So I will never be able to find one again that isn't very expensive, unless I really, at the time, 10 years ago, is when they were showing up in junkyards. That's not the case anymore. They're much more rare. I'll have to find another opportunity car like that, but used car prices have exploded, and I don't have space for a project car right now. Otherwise, we would be electrifying something. You goddamn guarantee. That's my guarantee to you guys, is that if I ever come across enough space to have a project car, if I can afford like a little warehouse, we will certainly be electrifying something. Right now is the time to act, though, because some of the rental car companies have sold their stock of Teslas. And a Tesla, that's a fast car. And you've got all the stuff you would need to electrify something except for the controllers that you can buy separately. So you can just pop out the drivetrain of the Tesla, make a bunch of really unique brackets to put it into whatever shell you have, and make a pretty nice electric car. Yeah, the 944 is a really nice Datsun 280Z. A friend of mine had one of those for a little while, and he sold it. This is my cousin, by the way. A friend of mine had one. It was white, and boy howdy, a white Datsun 280 with black wheel fenders is just you know, those flared oh man. Have you heard of Edison Motors? Yes, in passing. I don't know much about them. Make a Tesla. You could do that. I had a friend make a rally ready, oh, what was that car again? I forget what it was. He totally redid the drivetrain on like a Pinto, and he made it autocross really, really well. It was his autocross Pinto. It was amazing. Rental cars are expensive as fuck these days. Well, see, the thing is, you could get a Tesla, which is like an expensive electric car, and it's got a lot of bespoke stuff that makes it really, you know, kind of a nasty, good handling, fast car. It's actually a really nice vehicle, and so you can grab that stuff and put it in. It's like cheating off of the C-student next to you, stealing ideas from Tesla. Oh, from Edison Motors. Yeah, that's do you want to be doing that, considering how the Cybertruck went down? Keeps going down, keeps going up and up, going up in flames. But yeah, so anyway, that for just a little while, that's why I said now's the time. Oh, that's the wrong camera. That's why I said, like, now's the time to act on something like that, because those cars have flooded the used market, and you could have gotten one for like 10K, which is, considering the cost of getting the components on their own, like from a reseller or something like that, it's a pretty good deal. And you get the whole car, so you could use the seats if you wanted to. I would have loved to do that, not as a hybrid, but just as a bespoke electric, and then get whatever kind of a returning to earth car I could find if I had the space. And again, because I talked about it on stream, some of the Scandinavian viewers found a Lancia. I'm going to say Lancia. I know it's Lancia, or however you guys, you know, pronounce it over there in the civilized world. I'm going to say Lancia. That's just my accent. But the Lancia, they found a Lancia Delta that was in the exact shape that I love, which is, I've been working on this, but I stopped. So it had a bunch of the exterior pieces on the inside. It was painted in primer. It had another set of wheels with it. It would have been the perfect thing for me to buy and somehow get to a shipping crate and bring it over here. Lancia Boyle. Lancia. Yeah, listen, it's just, yeah, Lancia Delta. No, it's more nasal here in a minute. Lancia Delta. Lancia Delta. Oh, pinky's out. You gotta be in polite society. It's just my accent. You know, you guys could find whatever comedy in it you feel like, but I'm from Philly. You don't like us, we don't care. I'm from Philly, fucking Philly. You don't like us, we don't care. Bonk. Okay, so here is the PCB, and if you'll notice, unlike our previous representation of the PCB, this thing down here, all of these components had not been fitted yet. We put a lot of work into the front panel and making sure that the front panel would fit on its own PCB. With these 2 HP modules, what people do is they do multiple PCBs. We're better than that. Screw the Eagles. We literally don't think about you at all. It's pronounced rusty Italian car. That's what everybody goes, you'll have to deal with rust. I'm like, bitch, my BMW is returning to the earth as we speak. I can hear it crackling outside right now. The current British accent is an accent they created exactly after the Americans left. American English is closer to the British accents than the British accents. That, and you guys called it soccer to begin with. We didn't call it footy tooty rootin' tooty. We didn't call it that. You called it soccer and we kept the name. And then hand egg became football because we're just a bunch of, there's a lot of head injuries in football. So, I mean, American football. So, that's why we called it football. It's otherwise you wouldn't find people to play. But you guys started it. Apparently the Southern accent is closer to the way the Brits used to talk. But anyway, okay, so we've got the whole schematic here of what should work. If I pinch this onto the board oh yeah, there's supposed to be a gap there. As best I can, then I can route all the traces. We can get the board made. We can put it down we can physically add it to the rack. I can give it to Julian. He'll be super thankful, and then he'll come back to me with a bunch of little things that he wished happened better, and that can iterate into this design. Because remember, these are $5 a board. It's $5. It's a lot of computer work and a lot of assembly work, but it's only $5. So we can revise this over and over again, and we're still not even approaching the amount of cost that it used to be to create your own PCB. I love that about this. It makes development so much lighter and fun. So what I've been doing in the background when I finished up that other PCB to take a break from it so that I could check it over, I have been getting basically, that thing you do with your luggage where you like stand on the suitcase in order to fit everything in there? That's essentially what I was doing. What is this thing? So this is a 2 HP mixer, and the mixer is designed to take in 2 stereo channels. So it's got to be half of this size. It needs to have 3 small knobs. 2 of them are mixing in stereo channels. So you have right, left 1, right, left 2, and you mix them together. And then you have an overall volume knob that outputs to a headphone jack. That's what Julian wanted. And while there are probably easier ways to do this, if I really wanted to get like my circuit design chops, I could probably do this with op amps and variable gain op amp setups. The problem is controlling a right and left channel with one singular variable gain as like one potentiometer. I'm not sure how I would be able to do that without using like a dual pot. And dual pots wear away and they get scratchy. So you start getting a when you start touching your volume knob. And I wanted to avoid that. Then, because I'm dumb, I wanted to have some form of headphone amplifier, bespoke headphone amplifier that did some little things in the background to make sure that things are okay for like a set of professional headphones. So what I've come up with is a circuit that uses this V2164 chip. And what this chip is it is a, it's a bunch of voltage-controlled amplifiers, 4 voltage-controlled amplifiers in one chip. Problem is we need 6 voltage-controlled amplifiers, so I've taken 2 of the chips and hooking them up, because having those extra 2 gates isn't that big of a deal. We just kind of parallel them up. And then I found a headphone amplifier specific chip, a TPA 6120. I don't know anything about this kind of stuff. I bought one on a little board. This thing, I haven't figured out if this sounds okay yet. I should probably hook it up instead of my regular headphone amplifier and just see how this thing sounds with like a bunch of volts into it. I don't know. We're not going to be able to include this much capacitor. That's for damn sure. But yeah, that's sort of the idea here, is that we were putting together this mixer, and I built it on solderless prototyping board. And now I'm designing a PCB, and it's the sort of hobbyist pipeline, the computing pipeline, the physical design pipeline in circuits is such that you can jump into the PCB design very, very quickly indeed. So I'm just in this stage, what I'm doing is I'm just seeing if there's enough room for me to fit all the stuff. I did a minimal amount of work to make sure that these air wires were looking clean, that is not crossing over each other. That's just an X for the component on the other side. I locked the components on the other side, but like you're trying to make sure that things are relatively open and not crossing over one another. Like that's a crossover, but I can kind of tolerate that. And you want to, what I did is I took functional blocks. So on this schematic over here, for instance, if I wanted to do just this part of it, I can highlight it like this, and that's going to highlight all those components, and then if I jump to the PCB, it'll highlight the components that I have on the other screen. So now I know where my groupings are, essentially. So I grouped them all off of the board, got them all together, and then I figured out where certain things needed to fit. Like this chip is old. It's an SO16, right? I think it's SO16. Yeah, SO16. Oh yeah, this board flip. There we go. 1, 2, 3, 4, blah, 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 16. Okay. SO16, and as such, it is a very big thing in a modern design. I'm insisted on using 0603 chips. They're easier to work with. They're hand solderable. The 0402s, technically you can solder. These are, by the way, the numbers that I'm saying here are, those are the size of the chip. It's a literal inch measurement of width and height. There's also a system of metric measurements, but goddamn, are we bad at moving over to metric. So I still think of these in sizes 0805, 0402, 0603. 0402, those are smaller numbers than the other ones. That's an even smaller chip. It is damn near impossible to work with. That is this size here. Actually, I have a good way to peek in on this thing. This is Marbles. It uses that smaller size chip. That's a capacitor. Wait a minute. We need to find, yeah, there's one. Oh, that's a capacitor. That one's even larger. Okay, so I don't see any tiny chips on the edge of the board over here. There we go. See that? That's an 0402 right there. I don't want to solder that size. I hate it. It makes you feel completely inept when you have to solder a resistor that's that big. Here's my finger for comparison. So very, very small size chip. This is an 0805. A little bit bigger, easier to grip. This is 0603. So 0603 is our sweet spot. It's not, you know, utterly ridiculously small. It has a value printed on the top. And actually, this is 1206. 0805 is between these two sizes. Do we have an 0805 somewhere on here? I don't think I see any. But yeah, 0603 is a nice non-psychotic size to build things in. And so I would like to use those size chips. Now, I would have more room for traces otherwise, but we put into our design rules, we put in the JLC PCB parameters. So when I lay down traces, it won't allow me to put them too close together. But so I've been kind of just trying to organize everything on here and fit all the things so that we would have a mixer board that is functional and small. And the reason we can't use the other side, actually, well, let's bring this to the 3D render. That'll be an easy way for us to observe what's going on. I don't know how I'm going to be able to get that many capacitors in there. I'm going to have to do a bank of capacitors where the power comes in, and I can't use tall caps because the tall caps will interfere with plugging in the power cable. So what we need to do now is start layout. And when we start the layout, we're going to start with a prioritization of signals. So our first signals are going to be the ones that we want to be kind of smooth and go from end to end more easily. And then at the end, we do power, which will potentially bring us out to 4 layers if we can't figure that out. If we can't figure that out, we may have to go to 4 layers. I've been pretty good, like with the keyboard setup, I was able to run a lot of these traces without having to move to another layer, but things are getting a little bit close. There may have to be vias in some of these pads. This is only a representation of what's there. There's actually, the pads are in the right place. It's just a special component. Yeah, this is going to be, moreover, design is going to be difficult on this, but even greater difficulty is going to be soldering it in general, which is why I want to keep to the larger chip sizes so that I don't lose my mind soldering this stuff down. But the layout is tight, but JLC PCB supports it, and the reason we can't use the other end, the other layer, is there's stuff there. There's stuff there in the other layer. Technically, I mean, maybe I could hide like a surface mount component like down here in this little space. I really don't want to do that. Potentially there's space on either side of these. I could put some of the initial capacitors in here. That may be the way to go with some of these caps that I still have to put down. And then earlier I was thinking, you know, there's like a whole cathedral underneath this part. But what if I switch to a different potentiometer and it's not the same design? Not the same design as the 3D model. Then it's probably bad practice for me to put something down there. I had the 2 resistors associated with the potentiometer on this top layer, just right up next to the pads. I'm not totally sure I want to do that. I don't know if that's a great idea. It does free up a little room, but the only place that I could put the mixing circuits is here and here. So our signal path goes from, well, that's the control. It'll start here with the 2 stereo channels coming from here, 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 and here, and then go into one of these mixers. Then it'll go into the other mixer, where it then doubles back to this amplifier, where it gets turned back into voltage, and then it goes into the headphone amp over here, and then it's outputted here. Need to build a DIY PNP machine? I don't know about that. I'll be able to build this. You got to build it in a certain sequence. I'll be able to build this. It's a little tight in here, but we made the pads even tighter to accommodate for this sort of thing. And then there's going to be traces on this. This is going to be a nightmare. I'll have to also take a good long look at where my gates are. Like, having all the controls up here might not be a good idea. I may split the sorry, that's the end amplifier. If I have like this potentiometer going to this one here, and then this one goes to like this one over here, and then that frees up 2 up here. I have 1, 2 going to there. I don't know. Because it'd be input. This is these components here are doing the input shaping. They turn it into a current instead of a voltage. Then it goes into this mixer, where this one and this one go to here, and then go to the mixer, because we need the buffer. And then this one goes all the way back here to the top of the board, and then it goes into this one. Manual PMP is not too bad. I worked with a machine before. They're pretty nice. You put the right syringe tip on it, and you have a foot pedal that does vacuum, and then you have your little control that just physically moves the axis back and forth, and you have the spinny one too that spins your suction cup. And that's pretty good. I like that. And it was really good for putting down solder paste. So you could be very specific with how you're doing your solder paste. It just kind of linearized all of your movements so that you weren't like holding a pair of tweezers or pushing on a syringe in order to get it to lay stuff down. That's true. DIY pick and place. I have a bunch of linear rails that I could use to make something like that, even in a pinch. The twist axis would be something that I'd have to figure out. And then getting vacuum. I think I need to hook up a Venturi vent in order to make vacuum, which are loud. Those are loud. I'll have to buy that part. There's a part in VW's that's a little Venturi vent, and it's got little hose connections on the ends, so you could just hook that up. This YouTube channel that designed and built one, is that an auto PNP or a manual PNP? I think I remember you guys linking me to that. No, I mean, what I can do, I don't need to do manual PNP. I can literally just put down a bunch of solder and then plop the chip down and bake it with a nice syringe. You go horizontally over these things with the solder paste. You plop the chip down on it, and then you move it over to the oven, and that's it. And then that will bake all the components in properly. And I have the oven. Wexo sent me like a pretty nice soldering oven that we then reflashed with different software. So I do have the means to do this stuff. I don't know. I could move a resistor over to this side of the board. Particularly the resistors that are associated with the voltage level spread that the potentiometer has. And if I need to rework it, I could fit a soldering iron in from the side. flexi-pcb will put your parts on for really cheap too. I don't want to have to send them anything. I don't like doing that. I'd rather build this myself. It's good content and it's fun. It's fun. Building marbles was not fun, but building this would be fun. Vacuum pump is quieter, but makes clouds of oil vapor. Really? I've never worked with the vacuum pump. I know you've done a lot of carbon fiber. Carbon fiber stuff. But I haven't worked with the vacuum pump. All I know is that you need to get a little Venturi for some other stuff. Yeah, that would be good if I was getting like 100 of these to sell. Honestly, I don't think these would really sell all that much. I don't really think people, maybe some of you guys would mercy buy it, but so the resistors that I can move to the other side, they're the ones here that go to V+. I could potentially move this to the other side of the board, put it like here. Well, it can't get in the way of the outside, so let's just see. If I put that there, I put this one here. Well, it really should be, it should go like this. Oh, not this one. This is the one that goes on the other side. Here's the other one. Put them just right up alongside it, like that. And then let's flip to the 3D PCB and just see what that looks like. If it looks like I'm going to short out the solder or not. It works within the design rules. I also want to roundinate the corners of the PCB just for fun. And then either I have to go in with a file or we have to put a mill layer instruction on the side here to make a little cutout for the tabs. Otherwise, I burn an entire millimeter of PCB, which is a lot of real estate. I guess if the edge conditions are met, this will solder up just fine. I think this was moved so far down because I had different edge rules before. Because we really could have moved that up more. Well, I guess it is also even and within the size of everything. All right, Beef Daddy. Why do I call people by their real screen names? I really need to truncate that. That's something that I've noticed that Sark does. He doesn't call them by their full degenerate names, and it avoids him saying uncomfortable things like calling someone Beef Daddy. Oops. That is old school programming, troubleshooting things. It's hex. Do you have your favorite PC motherboard maker, MSI or MEG? I had kind of like Stockholm syndrome for those. What are the Brits? What's the British one? EVGA. But I've had a motherboard die live at a LAN party where every time we went into the BIOS, a new component would stop working. It literally died sequentially. So I don't know. Yeah, and their customer service isn't great anymore. So no, I don't really have good opinions about. Rest in peace, EVGA. What are they? Have they gone under? Yeah, so I don't have great opinions about motherboard usage. When I build a computer, I always just like spec it to the max, aim for the stands, and whatever I end up getting lasts me for like a century. So here's the problem with doing that here. I need to move these down a little bit. So if I do these on the other layer, they free up components. They do take up routing space, but then I got to be careful that they don't end up under something. They're long gone? Oh. When did that happen? I'm not aware of these things. The company is completely gone. When did that happen? I missed it. Yeah, that's what I was like. My graphics card is in this computer is EVGA. There's a 1080 FTW in this computer. All right, what's that look like? That's pushing it, but I guess it works. Let's compare the 3D model to the actual part that I have, though, because that's what's going to go in here. Let's see if I can find it. They stopped their partnership with NVIDIA with the 20 or 30. After that, I was downhill. I see. Yeah, I remember that partnership ending, but I didn't know that would be company ending as well. All right, so where do we have these things? These are these guys, I believe. These are the knockoff Alps that I'm using. As much as we deride knockoffs, they are kind of useful when you're on a budget. 3 people still work there? Oh my God. They were great for a little while. Then they kind of went downhill. And then I guess they went all the way down the hill. Oops. Micro spring arm, not spring arm micro. I don't know why my thing keeps scrolling down. So this is 100K. That's not what we're going to use. We're going to use 10Ks, I believe. Oh, this one is actually alpha. Okay, never mind. I thought they were knockoffs. And what we got going underneath is 4 big board pokums. I guess they really want this to sit off of the board. But they got these 4 big pokums sitting out the bottom. So technically, I could put those resistors in the middle if they are low enough and they don't contact anything. Find a board with a 603 resistors on it. Something like, oh, this has a bunch of stuff. Power supply board with a bunch of big caps. Yeah, so even the 0805 decoupling capacitors will fit under this. I am going to utilize that. Look at how much space I've got. So these would be pushing it because those metal clips right there. I want to be careful to avoid the metal clips. So if I have smaller decoupling capacitors, they could even go up to 0805, but I think this is 0603. This is 0603. So we can put 0603 components directly under our potentiometers as long as we avoid, because we're only going up like a millimeter or 2 on this thing. That's a huge deal. That's going to make a big difference here. So this is okay. Although the height of this thing, these I should probably lower down to the bed there. Although we're going off of this height. Is that different? Wait a minute. I think the actual construction is different than the 3D model that I have. Yeah, those are all at the same height with the alphas. So, I mean, this 3D model, like I said, this is the reason we're checking this, is that this is actually quite different. Now, the decoupling capacitors aren't going to need to be changed out, but I may need to change out these resistors. These resistors are going to be a bit of a problem because they're analog. They're kind of skewing the 2 ends of where the potentiometer adjusts. They haven't done a new motherboard since the 14th gen CPUs. I've had an EVGA board die on me sequentially. Is it smart to actually do that? No, it's incredibly dumb. It's actually the dumbest thing, but I think I'm going to get away with it. And that's all that really matters. It doesn't matter how dumb you are, just as long as you get away with being that dumb. And the other question is, hey, the Beatus, how you been, man? I'm on a sick day. We're just post snow day here. What I'm trying to do is fit a 10-pound amount of component shit into a 9-pound bag. So like things like this are actually not good. Where these tabs are going to be folding in, I need to move these components. And so I guess if we take the decoupling caps and we move them to the other side of the board under the pots, that's going to save me just a little bit. And I might be able to fit more components in. Well, these aren't decoupling though. These are the feedbacks. I can bump these upwards, I guess. We're at sort of that size of circuit board where things are very difficult to move. We've got a lot of little considerations here. That's not the right one. No. Oh, here it is. Put it about there. Crazy roller coaster of blood sugars. I was getting sick earlier. Site failed. I hate that because it's all at the speed of the human body, which is slow. Yeah, you're like, okay, are we done with this yet? No? Okay. Ground and V plus, but we have a jack on the other side, so we can stay over here with these components. Here we have a potentiometer. Is that up here? Yeah, so these need to move. But they can go to the other side of the board and go in like this. Stop it! So now we can get V plus and V negative from the other side of the board, even though this one's going to have to be, yeah, they recommended that you connect the heat sink to the V negative. And then on the other pot, these have to be on this side because there's a audio jack behind it. And this is the other pot. There's, oh yeah, we've got these two. So these can go here. As long as they avoid the center, they should be okay. Of course, this will put these right directly behind the metal. Oh, and there's still so many capacitors to fit into this thing. Oh boy. Can rearrange some of those later. Right now I'm just trying to get everything in. Everything has to be on this board and maybe a little bit convenient to solder. Yeah, okay, we can use this here. This one here. Probably a pretty stupid thing to do, but we're trying it. I have no space to put these on the other side of the board. That's unfortunate. Because I still have the capacitor that comes out of this thing, and there's no space at all. There's no space at all! Oh, man. So this is okay like that, with the decoupling capacitors on its sides. Let's just take a look at what the 3D PCB looks like, and if I'm comfortable doing it. So at this stage, I've got everything kind of grouped, right? Everything is in groups, and I've laid out those groups as best as I can figure out. Then what I do is mechanically make everything work, right? Get all the chips in the right spots where I could think I have enough room for traces. That can change depending on how hard it is to run the traces from thing to thing. But once I get stuff mechanically in the right spots, I will then go and start laying down traces. It's the part that you guys missed on the other board, and it happens very quickly. You know, your design starts to come together and many questions become few. In this case, I will have to prioritize certain signals. So if I say, all right, first things first, I want my audio paths to be direct and clean, because that'll keep them from getting interference. And again, I don't know how you design with capacitors. I don't know what kind of filtration I would need on all of these audio lines. I see all kinds of weird stuff going on where they'll add extra caps and, you know, every which way. I generally put my circuits down straightforward, and I don't consider what I might need in terms of like stamping out resonance and doing stuff like that. Like you may have a feedback capacitor on these, although we already have one over here, in order to get high frequencies out of here. Maybe something that I require later. Boy, do we not have space for something like that, though, in this design. There's not a lot of excess space. So from here, once I get them down onto the board in a proper spot, I can then start to weave in all of my design traces. And then we'll order the board, put one together. We'll see how terrible it is. We can see whether or not it's absolutely awful, and if a couple capacitors will fix it or not. I don't know if that'll be the case. I just don't think, I don't know. Yeah, I was able to get this capacitor in here, but the one for the left-hand channel doesn't quite have that space. And I mean, I guess I could move this up a little bit. Just gonna make soldering that much more annoying. Of course, this comes up, 2D, 3D is out of sync. Yeah, great. Please stop taking up all my space. I guess that's the only way that I really have to do it. Space these out a little bit more. This is going to be a very annoying thing to put together. I'll tell you guys that much right now. Yeah, we'll just do it like that. And then our chip has enough room here. Probably move that up a little bit. I want to stay away from like the chip and stuff, because all these pins are going to need to be soldered. But I can only get away with so much. Yeah, if you guys don't know, in diabetes, there's an unfortunate feedback loop where you want to get the body to change its glucose levels as fast as possible, but you don't see any results from that for like 2 hours. And when you have sugar, your body can process it nigh on instantly. It'll tell the liver to start releasing glucose as soon as you eat something. So it makes for this sort of nasty feedback loop where you're running at the speed your brain would like to consider things, and your body is running at the speed of chemical interactions. So it causes what we refer to as a roller coaster of glucose values, where you go down, you go up, you go down, you go up, you go down, you go up, and eventually you get a handle on that. But it takes some special, like, you need to be pretty skilled at your own body in order to do that. And at the same time, this is your body. These are your glucose levels, and they affect your mental state. And the brain does not have a diagnostic system internal to itself. It doesn't know that you're schizophrenic. It doesn't know that you're crazy. You're fine, but you feel weird. So what's going on here? Oh my God, I need sugar or I am going to die. We are going to die. Lizard brain goes, I need sugar. And you eat too much because it's delicious. And you know, oh, this is very delicious. So the feedback loops in the body are fighting against good diabetic glucose control. That's just inherent to the system, though. It's a very frustrating thing if you don't know much about it. You've probably experienced it before without even knowing. More time you spend on your blood sugar about normal. Yeah, and then the body, the wonderful thing about the human body, the reason that we are apex and the reason that we're at the top of the food chain is that we adapt to everything. We can live in poop smell. Welcome to poop smell. No, we can live in poop smell. We can adapt to just about goddamn everything. We develop the ability to sweat to regulate our own temperatures, like all that stuff. So if you run at a higher glucose level for a longer amount of time, you can get used to that. And so if you go to a normal glucose level, because your range of sort of feelings of glucose levels has shifted up, you don't feel that normal glucose level as a normal glucose level. You feel it as a panic and a need to ingest glucose, like sugary items. You can live in poop smell. You can do it today, yeah. Just move to poop smell. It's in Nebraska. I don't know. I'm just making stuff up. What's that? The more time you spend with blood sugar about normal. Happened to me this morning. I was still 200 after taking doses of insulin 2 hours earlier. Yeah, and when you go hyperglycemic, sometimes your body is going to fight you in moving that number. It's an unfortunate result. You go hyperglycemic and you need more insulin in order to bring it down for some reason. And then some days I'll give like a shot of insulin and it'll fire downwards suddenly. I've had times where I've nearly died from it bouncing in that manner. You get different insulin batches at different strengths. A site could get old, a site that's constantly being given insulin, your body's going to fight the foreign body, and so that insulin becomes less effective. Your pancreas can suddenly work a little bit sometimes. I've had that happen before. I've been able to eat something and it does nothing to my glucose level, which is a really bad precedent to set. Suddenly your pancreas is like, oh, I could drip feed a little bit of insulin into this body. And you're like, whoa, what the fuck's going on? And then other days it doesn't do nothing. Yeah, it's very frustrating. I don't think they communicate that properly when, for instance, you have insurers that will insure you exactly the amount of insulin that's been prescribed per month. And sometimes they boil it down to, you use exactly this many units. Well, no, I had a bad month. I used more. So yeah, finding an endocrinologist, a doctor that really understands that situation well, is super important. Seen something really sad the other day. Some scientists came up with a special insulin that self-regulates so you can't take too much. But then they sold it out to the largest insulin makers. Son of a bitch. I remember something like that. I do, I think. Use the fish tank analogy. A fish can live in their dirty water because they got there slowly over time. Yeah, but you come by and add, yeah, exactly. Yeah, you got to acclimate. But it's an unfortunate acclimation because a lot of diabetes that you hear about, the people that I'm always, for some reason, told about, oh, bother, I had an aunt. She cut off her foot. I'm like, thanks. A lot of there's a couple different types of diabetic people. That can be all kinds of different people, but there are certain people that just ignore the fact that they have diabetes and they get away with it for a while. It all comes crashing down eventually, but you know, the human body being what it is, some people just literally just ignore diabetes. I'm sort of a hit it in the face. Diabetic. Self-dose and insulin calculating correctly, and yet you go into a crash. Look, my body weight is such that never happens to me. I would like to be at a body weight that can accommodate that, I'm going to have to do some soul searching in order to figure out how the fuck I'm going to lose all this weight, because I have let myself go for too long. I am well overweight. I am a beach ball. So, are still in tandem? Oh, you missed that whole era, Beatus. Oh, man. Check this out, man. So, I can just go over here, and I can go to... Where'd that one go? Where's that overlay? Bonk. So, currently my glucose level is 162. I've eaten lunch, so we are coasting at a really good clip, actually. That was a poke bowl. Poke bowls are great. It's raw fish and kale. But this is live up to the minute. I have Android Auto Pancreas System. I'm using Omnipods, and I have the Dexcom G6. I didn't move to the G7 still. So basically what's happening is, as time goes on, X-Strip is communicating with the Dexcom. That's fairly common. A lot of people, X-Strip's been around for a long time. So I have X-Strip actually instead of the Dexcom software, because the Dexcom software requires you to like lock your phone down and do all kinds of other stuff to make it a medical product, whereas X-Strip is just made by some weirdos, and it doesn't require you to change too much, and I can turn off a lot of alerts that I don't need. Then we have the Android Auto Pancreas System, and that is micro-dosing insulin. It does a half a unit at a time, little tiny blips of insulin to mimic the way that your pancreas delivers insulin, and that is looping. So I've got it on a feedback loop with the Dexcom glucose levels. And as you can see here, I ate the poke bowl, and then it realized my glucose level was on the up and up, and it decided to inject lots of little tiny little things of insulin into my arm, and that brings me back down to normal. It's all automated. So my A1C, although a little bit high, mostly because the glucose control is very slow because I'm fat. I have, a little bit of type 2, a little bit of type 1. I'm multiple types. But anyway, because I'm a big fatso, it has trouble controlling it. It needs a lot of insulin. When I eat a meal, I will use the calculator to tell me how many units, and then I'll manually inject it just so that I can keep the pod on my arm without having to replace these things constantly. So, oh yeah, I don't know about the Beta Bionics list. I don't know about that stuff. I keep insulated from a lot of that. You guys are some of the better contacts that I have, and people who I found through just doing the diabetes stuff. I was on the diabetes Reddit IRC for a little while, but I haven't really kept too far up with them. So I don't know where stuff is right now. How long does the Omnipod normally last you? I feel like, the more I've seen people talk about like how many units they use a day, I feel like sometimes I'm in line with those specs, and sometimes I'm well out of it. I don't know who the medical companies think is using insulin, because I go through a lot of units a day. I can have an 80 unit day. IRC showing your age. No, that was at the very beginning of Discord. No, we were using IRC up until fairly recently, up until we all switched over to Discord. Curious about sometimes manually inject yourself? Yeah, while using the pod. You can tell AAPS, Android Auto Pancreas System, that you have eaten carbs, and then you can also tell it that you've injected. So in terms of record keeping, this thing still has all the pertinent data. Unfortunately, you can't do that when the pod is inactive. You can't tell it that you've injected insulin manually when the pod's inactive. Maybe they fixed that for 3.0. This thing has been bugging me about upgrading to 3.0, and I haven't done that. But anyway, what was I on about? The Omnipod makes it so that I can't get away from the control. I can't unclip my pump and put it to the side. I use something like 80 units a day. So this thing barely lasts 2 days, right? 80 and 80 is 120. This thing holds only 200 units. And Omnipod, I have it out for those guys, because there's a lot of design in the pod that makes it 100% unreusable. Right? It's one-way streets. Every single branch of the technology of this thing, the way that it injects the cannula, the way that it advances the cylinder that holds all of the units of insulin, the way that it moves that motor is with memory wire and a little pawl that goes back and forth. It's completely unresettable, right? And then if something goes wrong with your pod, you tear it off, you throw it away, and start with another one. Well, these things, while they are $30 of technology, they sell for hundreds a pod. You buy a pack of 5 pods, it's like $400, right? So for the insurance company, sure, but I mean, that means that somebody like me who's on a public health plan right now, if I make a certain amount of money, I get kicked off the plan. I have to personally fund all of my diabetes gear. I can't do that because the amount that kicks me off the public health plan is not enough for me to continue my my method of treatment. Method of treatment differs from person to person. Some people are fine with insulin pens. Some people have a CGM and an insulin pen. Honestly, I think CGM should just be given to every single human being. The ability to have a CGM should be universal because it teaches you stuff about your body that is just mind-blowing. Obviously, especially for diabetics, I think it's more important than insulin pumps. Even though insulin pumps are a wonderful piece of technology, the CGM is game-changing. It completely changes everything about your management. You get to know your body, how it responds. You get to know when you're going to overreact or underreact in terms of giving insulin or eating food. Yeah. Every person, if somebody who exercises a lot wants a CGM, they should have that available to them. The whole prescription plan pricing has kind of fucking ruined that for everybody. Like, there's that EKG thing that you can get where you put your fingers on it and it's like $100. If a pack of 5 pods was $50, which is kind of what they claim it would be with insurance. If a pack of 5 pods was $50, if a CGM was like a, I don't know, $20 for the patch and then $100 for the transmitter, I think that would be more reasonable. Like, and it would be available to everybody. It would, change stuff. It would be great. But what do I know? What do I know? Golden information, really appreciated. Oh, thank you. Thank you, Vault of Shabur. Yeah, but I'm talking about, I'm here in North America, so everything that I'm saying is a North American, suburban to the core, just fucking weenie. So, yeah, why wouldn't they sell this over the counter? Well, it is invasive. That's a big deal. I think it should be over the counter, but it involves a syringe that goes into your body, so that makes it in a different category entirely. But it really should be. That would be great. Dexcom's Stylo came out for the public without prescription. They can get a month for $99. Yeah, that pricing is still fucked. I think it should be down more. And especially these companies, they keep producing these products, and then I guess they innovate in order to keep the price up. But really, their manufacturing should make the price go down. It would be nice. It's not that expensive, the technology. I mean, when you do it on scale, people say, oh, it's so expensive because they have to make it sterile. And that's not true. Like, at the volume that they create these devices, adding a step to it to make it sterile is like nothing. Here's a radioactive isotope that we just fly our boxes by every now and then. Now it's sterile. Like, there's not that much considering how automated manufacturing is these days. Like, yeah, it's not that hard. Potential interference. I have not had any huge problems with interference. There have been times when things have not connected over radio quite properly. I've had a few confusing times because they built something into the CGM where if you try to start another CGM with the same code, it will lock you out for 15 minutes. And I didn't know that was going on at the time, and I wasted a lot of my supplies swapping them out. Yeah, the workload stays the same with automation. Yeah, it's one of those things. But yeah, so anyway, that's my perspective on all this stuff. I didn't know about the Stylo for $99 a month. That's a little crazy. And then Dexcom. They had 2 separate parts. One was a transmitter, the other was a patch on the body. They made the patch on the body smaller, and they merged the 2 into one. So now the wire that goes under the skin that senses the blood sugar, that wire is just inherently attached to the transmitter part, which would be fine if it was cheaper, but that means that at the end of the 10-day, I guess you said month, so it's probably a couple devices. But that at the end of the life that they determine on that object, they can just say, we're done, we're not doing signals anymore, and you can't replace it with anything. I had a guy who I knew of a person in the diabetic IRC, for the Reddit diabetic IRC, who had a CGM on their ankle, and their sock kept it nice up and flush. And I don't know what it was about their body, but they didn't reject it as quickly. They were able to run that for a month, restarting it and getting it to do the levels again. So, some new inexpensive CGMs coming out, but they're kind of special purpose for pre-diabetics. Well, that's a good technology. Suspicious blood sugars may be imminent or detected by tests. So they, yeah, I know the Libre, you have to like tap in order to get a bunch of levels at once, whereas Dexcom just connects at all times. And although my generation stores quite a bit of data when it's unable to connect and gives a big packet when it reconnects. I've had times where I've gone upstairs and I've left my phone down here and gotten back to it later, and it was like, oh my god, here's like 15 of your levels. But there's still a big gap in records keeping. I can reuse my Dexcom G6 for about 25 days. My body rejects it within 10, like it's normal. I've re-upped this one and it seems to be doing okay right now. I think I'm probably gonna have like 4 or 5 days and then it'll just start giving me wacky numbers, at which case I'll have to actually replace the patch that it's going to. Another thing I've learned listening to you is that you need to be within range of your cell phone. Basically, your cell phone is one of your internal organs, which I'm totally fine with. I'm a millennial. I'm always close to my phone. This thing is the whole world in my phone. I'm never bored. Actually, I'm bored a lot, to be honest, but still, I have no excuse to be bored. This thing is always connected to me. No, it's not a derailing. We're playing around with circuits. It's very easy to get distracted when doing this stuff. And I'm happy to communicate because this is a major, like, life-changing kind of set of upgrades. I had to learn a lot about it, and the training was obnoxious. Because, you know, it's a third-party app. It's it's just some guy who made the app. You have to compile it yourself because it's a medical product, but then you have to go through this really crazy training in order to get everything correct. And it wasn't so bad. That wasn't so bad. I was okay with that. But it was a lot. So these have to swap like this, or, well, no, because if I swap this over to here, then it's just going to make the control connections weird. What's that? There's one glucose monitor, I believe, that has an external reader that you can place around the house. Oh, that's weird. What's it, like IP based? That's a strange one. I don't care about being tethered to my phone. The only problems I have with that is when I'm pooping. You can do auto routing, but I don't trust auto routing. Auto routing is not really all that great. What we're trying to do is we're trying to make the air wires not interfere with each other and be as clean as possible before we start putting down our traces. Once we start putting down our traces, things will start locking in place. We're going to start to get a sense of what needs to be where. Right now, the big debate was, could I fit all of the components on here? And possibly we could do a 2-layer board with this. I don't know what it will feel like when we get backed into a corner and there is no other option but to go with 4 layers. I don't know what that's going to feel like. I've never done that before. Yeah, those are the two 0805, I believe, sized capacitors. Now we know from looking at this thing, even if our capacitors are absolutely enormous, they will fit under this component. We just have to be careful that they don't interfere with these metal clips. See, what you guys aren't noticing right now, and it's fine that you don't see it, but when I go to reach for something, my fingers are starting to cramp up, and I have to, like, close my, that was index finger was doing that. See that? It's trying to, my muscles are flexing because my glucose level's coming back down. Whoa, that's a really annoying thing. The Charlie horse phenomenon with diabetes is very annoying. They're allowed to cross each other. We just want to make it as clean as possible because we're able to lay things out more cleanly if the lines don't cross over. Air wires, as they're called in this software, air wires are just this pad goes to this pad. That's all they are. So you want to kind of clean it up and give everything the best opportunity to get directly to where it needs to go. through hole things go to both layers. The blue is only on the back side. Red is the front layer. Right now we've mirrored the board, even though it doesn't matter that much, but we've mirrored the board and we're viewing it from the back side. What's up, Nelson? That's a fine emote to use. And so technically we shouldn't be seeing the other layer because I'm only designing the back side right now. But yeah, so that's sort of what we do. We arrange things until they look kind of nice, and then we can start to lay down some traces for everybody. This whole section is a little sloppy. Some of these aren't on the grid, and I forget. Does anybody know, Eagle, do you know how to get stuff to snap back onto the grid? What? Can I deselect you? Not even supposed to be selectable. It's not even supposed to be here today. I don't know if I want to keep the center open. I think we can just live with this the way it is. It's just none of this stuff has really been put onto a grid. There is an arrange tool that I can use, but then I need to know what these millimeter distances are. And I don't know. And there is some button that you can hit when you selected when you select a component and move it around. You can hit one of these buttons. I forget what it is, and it'll snap the component on to the grid if it's been moved off of the grid. I made the mistake of not having my grids properly represented. The default is 1.27 and then 0.127. That's not good enough for this size, so I actually knocked it down to 0.127 and 0.0127. I really should be going with a more rounded millimeter, but that's what I've been using. If we're using SO parts, I believe these are millimeter spaced. So yeah, I probably should be using all millimeter. That was just for the other board. The keyboard board used parts that are through hole, and those are locked to a 1.27 grid. What's the grid spacing on these terminals? I think they're still on English. Let's just double check with that. I can open up a datasheet to do that, like a Max 309 datasheet. I have a lot of windows open on this computer. It's no wonder Chrome doesn't just eat it. Sound set, yeah, here, we'll get the pin pitch through this. Oh, assuming that there's any mechanicals on the datasheet, which there aren't. Where are my mechanicals? Ah, you bastards. Ah, you bastards. This is the research phase of the project. What the hell? Oh, Cabin Tech. Cabin Tech is where I'm sourcing these things from. Cabin Tech is a lot of these harder to find, very eclectic, audio-based electronics for like used in modular synthesizers a lot. A lot of really cool chips on this site. I got to read through what they have. This is the 2HP modules. That's just inspiration. This is a mixer circuit that I don't need anymore for mutable instruments. Most of the stuff we're making, I'm basing my circuits on mutable instruments because they are legendary circuits. They're legendary modular synthesizer units, and we have full design documents on them. God, that acid in the sinuses thing is still going on. Yeah, 1.27 pin pitch on these. So these are still in an English standard, which is unfortunately. Can you not delete your own YouTube messages? That's fine. We won't take you to court over that one. So these are 1.27. So these are an English standard on SO parts. I thought we got out of that in the SO era, but I guess that was the 90s that we moved over to that stuff. So that means that I'm stuck with my 0.1.27. What is that again? It's well, actually, unfortunately, this is in the middle of the 0.127s. Where's the grid? We'll have to figure this out later. I can delete any message that I have an error in when I use YouTube. That's how we do it here on Twitch. Oh, on Twitch. Yeah, on Twitch, it's just, it is what it is. Don't worry about it. Don't worry about it. It's fine. All right, so I guess I've got something of a layout here. I've got this mostly worked out. I think this one isn't even going to be populated. Well, we'll keep it over here. It does the mode for the 21 for the mixing circuit. Yeah, that one too might not be populated. I've got a little bit of space right here. I may decide to put a couple capacitors in there. I mean, looking at this headphone plug, looking at the design of this thing, like, that's a lot of capacitors. I'm certainly not going to put a through-hole capacitor on there because that's a real pain in the butt to do, because that means I need to trim the leads like really, really well. But all these capacitors, this is a lot. I don't know. Is this going to cause undue circuit draw on the rest of the stuff when it goes to really move those speakers? I don't know. I don't know. I guess we'll find out. These are only $5 for 5 circuit boards, so if I need to drop a bunch more, although $5 for 5 circuit boards, then we have 1, 2, 3, 4, 5. We have like $50 in chips on the thing. How many layers? Right now, we're trying to do 2, but it's not looking too good given the density of all the stuff on here. It's not looking like we might be able to accomplish that. I could be a funny guy and put everything at a weird angle, make it like 45 degrees. Now, we'll keep this fairly straightforward. With the 0603 chips, we don't have a ton of room. Yeah, this is going to be fun. All right, well, I guess we can get started, like, what is it? Function by function, right? So if I start from the back end and I go up, I guess that's one way to do it. Or we can skip around and do a bunch of them. But it looks like, you know, this is looking fairly straightforward aside from a couple places I really have to squeeze in traces. 4 layers, yeah, 4 layers is not that bad. If we go to JLC's website, we can just show. I had one open before. So if we're doing FR4 and we have 4 layers, it's $20. Like, that's not too bad. We're definitely in a situation where doing that many layers is going to possibly be completely necessary. And so with their default 1 ounce of copper, we have, that's via hull, board outline. I guess they've got it in the other documents, their limitations, but we have a certain amount of spacing that I've put into the program. And so we can put down our minimal trace, which 0.2 is way too big. That's a reasonable size for like a normal trace, but we're dealing with a very dense design, so I'm not really sure that I can get away with doing that. I mean, I can try, at least for these audio signals, I can keep them on larger traces. Let's see, let's just start with the audio signal and then see if we need to have much, much smaller traces for everything else. Now, this is going from there to there. I would like to use these sort of rounded traces a lot, the 45-degree angle ones, or I could use curved traces. We could do something like this. See, that's snapping and it's making my radius different. And then when I do that, it changes. Jeez. I still haven't figured out a way to work through that. That's one of the big issues that I have. And if we're doing it this way, I would also do a trace like that. Why did it get rid of both of my curves? Wow, it's doing a lot of weird stuff. So I'm coming in here with a trace, and I'm trying to click on that right there and go to here, but I don't want it to override the curves that I have. Because then if I do the curves, I can have that. And that's a nice little layout right there. We don't really need that to bust out over there though. So I can just do this. I can do that, and then to come to this one, and just go from down here. Why did that whole thing? I don't want that radius to be so big. What's this corner radius? From to layer round, curve 90. With, where's my corner radius? There's some things that are a little bit different than what they should be here. Usually go for 4 layers just to have a nice ground plane. Yeah, that's one consideration too, is that if we're doing audio here, if we go with 4 layers, then I can have internal signals with a ground plane on either side of it. It'll certainly make it cleaner for interference, but then again, we're going to be inside of a Eurorack panel. So what kind of wibbly waves are going on inside of a Eurorack panel that we need to worry about? I don't know. Okay, so I'm trying to kind of like rein in the curves here. I guess these all have the same radius, they just have different lengths. I'm just trying to get this to like match the other curve, because if you have a bunch of different sized curves on your design, it looks weird. There, you can do it, come back in. What I do is come back in and then you click on the curve and you can move it diagonally in order to make it larger or smaller. So if I keep this 0.2 for audio, that means you're actually able to see the traces. That's not what we did for this other design. The other design is for the flexi-PCB. These are immensely weeny little traces. These are, what are the width on these? These are 0.12, I think. Now the capabilities of Fusion say that they can go much smaller too. These are 0.1 millimeter, which I think was a compromise with their minimum size. Is that right? Yeah, 0.1. I think they can go down to like 1, well actually 0.05 maybe? Let's just check what the Fusion specs are. I have this open somewhere. Yeah, here we go. So this is on the flexi-PCB. 12 micrometers for the typical board service. 12 UM is 0.012. Yeah, 0.012. And I'm using 0.1. So actually I'm much larger than their typical spec. I don't want my traces to burn up. $4 mil for 1 ounce. But the default, the cheap one is 0.33, so 3 mil in millimeter. 0.07. Well, we're 0.1, so I mean we're much larger than the default on that. But that's for flexi-PCB for rigid, and then the default for rigid is what? 1 ounce. I need my spacing, my tracing spacing. Sorry about light mode. It's just I don't control over these things. Multi-layer 0.09 rather. 0909, and I think I have it set to 11, so we're just within bounds if we do a 4-layer PCB. So yeah, right now we're tracing these in 0.2. We could go to this size, 0.1. Oops. We want, nope, not you. We want this one. This is going to be pushing it a little bit. All right, router coming through here and give it a nice little curve to look good. It's literally just to look good. People may justify their curved traces by saying, you know, it's a healthy body, or this is just how I was made, or I'm big boned. But no, the curved traces are literally there just to look good. With audio signals, we're not going to be worrying a whole lot about you know, high frequency interferences and stuff like that. It's just not really going to be present. Let's flip this goober around, because that one goes to ground and it goes to this pin. V plus is probably going to have to go to a VIA. So N39, we're going to want to avoid, if I go here, now I have plenty of room for V plus. N39 could make its way across there and down. That's a little bit sloppy. Pull that around. If I do out this way, then I've got all this room here to do a V plus. Or I just go in for this. The signal priority is first thing, so I guess we'll just take it out of here. I may go to a smaller trace size. This is very big. It feels very big. And these are just sort of the first foray into it. Man, I really need to fix these resistors. The resistors are, I believe, from SparkFun originally, or these are the Seed Studio ones. Either way, what's happening is they're off the grid a little bit. So that one needs to be on the outside of the other one. So actually what I'm going to do is I'm going to rip up... Oh, that's bad, because this can only like exit this way to go to a via. So what I'll do is I'll just try this first. This is actually going to be symmetrical when I'm done, because it's right channel, left channel. Oh, there's a trace inside of there that's keeping it from moving. Delete that. And then we're going to grab this, spin it around. Like that. And that way I can come down flat with both of these so we can see whether or not we need to avoid. That's really tight. I don't like how tight that is. And then I need to go diagonally a little bit to get through here. Going diagonal with this isn't happening, so we'll use these. Just move it over like that. Go to curve traces. Maybe like that. It's a hell of an audio path, I'll give it that. And this one, eesh. Yeah, see, that doesn't work. It doesn't quite get it there. Let's take, just move it up a little bit. Those are not going to work with me very much. Ah, my smooth transition, no. Getting used to this grid still. So I guess I can push that out a little bit and let's unroute that. Try again. Oh, they got rid of my 3-click thing. Used to be able to click on it 3 times and it would unroute the entire path. Now there is an auto router, but it does a lot of weird stuff and I don't know if we really trust it to lay out our circuit. Make sure these are on top of each other's grids. I don't really have much of a choice. There's nowhere to really route traces until I go with smaller vias. Oops, left some things in. And then one thing that I think they added is that when you have a segment in the middle of your trace, it will actually make the 2 pieces of segment one. Yeah, I don't know how effective the auto router would be with this layout. Although I'm struggling with this layout. I guess. I guess. That's a little weird. LA is on fire again. Doesn't that always happen? We're on snow, they're on fire. This looks like it could move over a little bit. I didn't check the placement of some of these. I may want to try to align them a little bit. Yeah, because like that should be 5. How's that exactly 5 by 5? Although that might not line up with the grid. No, don't get rid of the flat part. Oh, that's so frustrating. There we go. Oh God, what a terrible one. That's a terrible one. Made worse in part by the fact that I talk like that. Negative voltage of both sides is over there. Positive voltage here. Positive is both sides here and here. The unfortunate part about this is that V plus is on kind of a hard to get spot. V minus is down here, and then our outputs are on the same one. This is a very strange layout on this thing. These three are no connects. So we've actually done a pretty good job to get most of our layout considerations. Now if I can come, oh no, design, don't take that out of context. From here, like that, make this a similar radius. We'll pull this in a little bit, like that. These are the kinds of three-way junctions that I like making. I kind of avoid making them because they are a bunch of overlapping traces. They look nice when you're using curved traces, though. Although having this thing do those 45-degree traces might be another neat way to do things. Well, take old projects and update them. All it takes is time, and oftentimes a lot of time to get designs right and updating them and doing them into CAD. But it is you know, hey, it's fun stuff to learn. Now the via is, I don't know if I programmed a default via yet. We know what the bottom spec is for one. So if I do this on the alternate spacing, and that snap is very annoying. It snaps from way too far away. I don't know, I could probably control that in the settings somewhere, but I'm trying to get it to come off of here, not there, but it just assumes that I'm snapping everything. What the fuck is going, like, oh man, there's some conflicting stuff going on here. So the only way that I can really get to that trace is through a via now. And so I guess I can put one right here. You just center click to do that. Center click, via goes down, and then we come back out on the other side of the board. The other side of the board, unfortunately, this is going to be fairly simplistic, is I'll just come over like this. That's a little close. We'll try to move it away a little bit. No! Stop it! With your freaking snapping piece of shit! The snap is really obnoxious today. I don't know what's going on here. So useful. Thank you. I guess I can put it there, but I don't know. I don't like that. I have to do the same thing on the other side. Oh, and it violates the distance there. Yeah, do we think that this size of trace is not going to work out? Yeah, I tried. One of them doesn't let me do, like, the alt spacing is, I think, all I really get. Try and see if there's a better one. Yes, the curves help electrons get to their destination better. Like, this is what I want, basically, just like that. But if I go to the other layer, it goes, and then it either snaps or it pushes stuff out of the way. If I go to alt spacing, that gives me slightly more control, but I don't think there's one that makes it ignore shift, control, alt. There's no really other hold controls. What I'd want is basically one of these T intersections right here, and then have the via be basically just right there in the center of what I'm trying to do. I could move this trace up a little bit and make it come up and along here. This has to go into the next thing, which is far, far away. Oh my God, it goes all the way. Yeah, that's one of the ones that has to do a huge distance. Usually one you can press and hold to make it ignore snapping. On Fusion, you know, it might not be something on Fusion. Let's insmollinate. Let's go to the smaller traces. We'll go 0.12 and see if that gives us enough space. Power traces, of course, are going to be larger inherently, just so we can get everything everywhere. But the signal traces don't necessarily need to be that big. They're not really going to be pushing that much current. Then again, this thing is going to be going to a pair of headphones with 1.7 volts. How much trace am I going to need for that? we'll find out. We'll make a mistake. Guess what? We're allowed to make mistakes. And actually, that's kind of why I get so nettled when people are over-helping, because mistakes are fun and funny, and there's something that we have the luxury of having here. Because it's a lesson. How do you determine the size of trace? Okay, so it's all ballparks. Everything is ballparks. But you can do a trace width calculator. Oh my God, all in caps. If you're doing a circuit that's like doing work, if you're actually like moving motors and doing stuff like that, you're going to want to consider that, because if you have a certain amount of current on your traces, it's going to cause them to heat up if they're too small. The wider your trace is, the less resistance is going to express in your circuit. And we're talking about very tiny numbers here. We're talking about very small effects. But if you're doing something like turning on and off a motor, you'll want to make sure that those traces are wide enough that they don't heat up, expand, and microflex your board, because that can lead to cracks. But that's, again, a really in a corner case. We're doing audio stuff. There's no current running around. It might be prudent for me to do some of the calculations, but it's a basic V equals IR, and so you can give it however many amps and how thick the copper is, and it'll give you a ballpark on what the trace size is. In our case, I am trying to give it as much leeway as possible. How big can I make my primary signal traces? More actually to communicate with the user where the signal is going. If I got to troubleshoot this thing, I want to look at it and go, okay, I kind of see where the signal's going. But in the back of my mind, I'm thinking, if this thing has to drive headphones, how many watts is it going to be running on the thing, and what does that mean for the amount of copper that I need on these traces? If we didn't have such size considerations, I'd just say whatever a big size is. These are huge on this thing. This thing has like enormous traces on all of its stuff. So I'm kind of ignoring physics. And then the via size, those are going to be in our rules, in our design rules. And we can compare the design rules to what JLC PCB's manufacturing capabilities are. So they got this page where they got all their stuff. We can make sure that our vias, so we look at, I don't know if I want to show you guys my holes on stream. Drilling. So drill diameter, hole size tolerated, blind to bury vias, I don't want those. Minimum hole size diameter 0.15, 1 layer NPT only, 2 layer, and then what about preferred minimum via hole size 0.2. Via diameter should be 0.1, 0.015 preferred, larger than hole size. So it should be 0.1 and then 0.25. That's our clearance. Are these the right rules? I don't know. I think we got the JLC PCB 2-layer, yeah, I just put these in. SMD via and pad clearance. Drill clearance, I guess we got to go to, yeah, I've got 0.15 and 0.13 for that one. Preferences. Annular ring, no. Pads and views are defined in percent of the drill diameter using min and max. Although we have already messed with these. These look untouched. 0.127 and max is 0.5. No, JLC prefers you use Easy EDA. We're using Fusion 360. Headphones would be in the less than 10 watt range. Look, the size of trace that we're putting down makes it so that I start to think about, where is that other 3D? Oh, we didn't render this one yet. The size of trace that I used in the keyboard thing makes me worry about, you know, if this size trace, because remember, okay, this is the surface mount component. That thing is, oh, I don't have one to show. Okay. It's like thinner than this, thinner than these traces, right? I'm worried about the amount of current going through them. I think they'll be okay on this one, at least for the keyboard, but like for the headphones, if it's even approaching a watt, I wonder if I need to consider that. Maybe not, maybe not, maybe it's fine. Oh, we don't need to select these anymore. I'm just trying to get it so that it puts down the via of the right size, and that we're somewhat near the minimum sizes for everything. I think we are, but I just want to make sure. So I think, I mean, I have my design rules in. The preferences, I mean, what is this? Is this the what I'm looking for? Annular ring? I have no idea, so I'm not going to touch it. What size via are we putting down right now? .35 drill. That was for flexi-PCBs, from what I recall. What's our, I guess they're automatically doing the diameter, yeah. Outer layer diameter is 0.5, inner layer diameter is 0.5, drill is 0.35. Where do I set that up? Oh, scroll down. There we go. That's what I was looking for. This for some reason was made smaller than it should have been. Right, so I control the whole size here. So 0.35 millimeter, we can go way smaller than that. Let's check again. Preferred minimum via hole size is 0.2 and 0.35 for the ring. Let's make this 3.5. Well, we need a 0.2, and this one's 0.35 mama. You think about that. All right, so let's get rid of this here. And now our trace size is 0.2. We're going to go to 0.12. Let's unroute what's left. And go to routing. Check our settings, 0.12. And then 0.2 on the via. And now we are a slightly smaller trace. I should be able to get the weaving that I need to get done. So if I look at the via size, that's our via size now. That is psychotically small, but it's able to do this because computers exist. So we can come right out of here, make a little turn. Yeah, it's frustrating when the snap is a little too close. And actually, you know what? Probably can do the different kind of bend, this soft bend. I'm on that layer. No. We're on the wrong layer. We're designing this from the bottom to the top. So the top is, I'm treating it like a bottom layer, but it's actually, you know, it's where I'll do all of the voltage stuff. Well, that's just going diagonal. That doesn't look like anything. There's no softness to that at all. That ain't right. No, that's not good. Okay, we'll go back to curve traces. I gotta learn how to make some of these bends look correct. So that one's going this way. Going to the side of it, I guess. I don't like going into the side of it, but this thing doesn't give us much choice. The amount of space that we have here doesn't really give us many options. Oops. Move that up by 1. Go. Just trying to keep the grid kind of even. It's a little cursed. It's a little cursed. So this one up through here. How close can we get to this? We can do it like that. I can just go directly in. And this one coming out here. Although it's a little spaced out, that'll be fine for our routing. Oh, that one's off by, why was that off by a little bit? What did that? Whoa. Really? It's that snap. That snap is going to be my worst enemy during this. Terrible. See, where I'd put this, I would like to grab my signal and do a different, you know, a little cover thing, but the snapping is, I gotta look to see where the snapping is. It might be in my preferences. That's not what I wanted. I've got to get rid of that snap. It's killing me. Oh, I think they're over here. Preferences. In space on the HD600, it uses 3.3 milliamps to push 97 dB, and it was 97 dB per volt. Oof, crazy. Electronics. Dark, cursor dark, blah, 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 blah. Wait, do we get dark mode yet? Mouse wheel zoom, legacy command line focus, limited zoom, show interference, new drawing up, always vector font. Beep, check components, blah, 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 pad names, snap length. What if we make that 2 mil? Maybe that'll help me out a little bit here. It does indeed. Okay. That just got rid of what was already there. That's a weird one. Why are you deleting my... Why is it doing this? I don't know. So snapping, deleting the circuit is beyond me. Why would you do this? Back to preferences. Dun, 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 dun. Auto end net and bus, auto set junction, route width and drill, group command on, enable GPU. I want to do flex, a project with flex, but I'm too broke for that right now. Flex. 2 layers, 100 by 100 millimeter. One design, yellow in color, electrodeposited. Enig, I don't want to say that the other way. Gold thickness. Outer copper weight. All defaults. $2. JLC is this deal going on. It's insane. $2 for 5 flexi-PCBs. This is why I like my 90-degree angles. I like the softer feel of a nice rounded trace. But I don't know what they did in order to make this, like... Is that optimizing? That's probably what it is. Let's see if it optimizes. That's still doing it. The heck, man? Preferences. Optimizing. Drills, auto end, net, and bus. Auto set junction, maybe? No, that's not it. What's doing that? Oh, that's so frustrating. You're not helping me at all. Fusion. Auto end nets and buses. Nope. I don't know what the preference is going to be called. Yeah, 100 by 100, $2. That's insane, right? Flexi-PCBs used to be like $500. Like, they used to be absolutely incomprehensibly expensive for us mortals. So for me to flippantly just make a PCB, a Flexi-PCB for my keyboard that utilizes the ability to bend the pins down here and take over the job of the two chips this was outright. This is the audacity of the engineer to do this. But now the $2 for 5 of these is like, pfft. If this were still like $100 to make 5 of these, then I would definitely be putting the RP2040 down directly, making this as small as possible and doing all that stuff. But now I can say, hey, I got a bunch of this fucking trash sitting around, right? All these parts that I don't need anymore. I can make them into the computer project only on a PCB with no wires. Cool. You have rounded traces ticked in the tool window itself. Yeah, I know. What do you mean? Let's take a look. Is it join type? No, I mean rounded is what we want. Loop preserved, maybe? That may be what it is. Let's check. That's what it is. Okay, so that was the setting up here. In the loop settings, I had loop remove. So it removes the traces that the traces go over. I need to keep it because I want my nice little intersection here with crosswalks. You know, the crosswalks are here, and then you got the rounded corners so the cars can drive around. Lawn Dog actually made that joke earlier, and I glossed over it. Although I could turn this thing around and have it come out here and go down. This needs to take a journey, so that's going to go to a via. God, it goes a long distance. And this is where you debate about whether or not you want to gate swap to flip things so that they don't overlap as much. Yeah, thank you, Tater's Game. That was exactly the problem. So getting N39 out of here, or this one is going on a long journey. This one goes where? N29? That goes here. If I flip this top and bottom, I can get the traces to where they need to go. So let's do that. Let's unroute this stuff. This is sort of my process here, is, you know, you try stuff and it doesn't work, and so you try something else. You learn that certain components are best put in certain places. Oh, there's a piece of a trace right there that's keeping me from doing that. So if we actually put this one here and this one here, look at those lines. Beautiful. That one is still a bit of a problem. Yeah, unfortunately, I can't do the trick where you go inside of this area. Auto trace done. I don't think auto trace is going to have a good time with this. I remember I saw some audiophiles argue if direct straight 90s affected audio quality or not. If what? Direct straight 90s affected. Oh, the 90-degree bends affected. I thought you meant like 90s design or something, like the era. Or if curve traces are required for PCBs. No, they just look good. They just look good, that's all. AI auto trace could probably handle it, and Altium has had AI auto tracing for many, many years. I can't afford to even look at Altium. Here we go. So we're going to go around this. This is what auto trace would do. And then into there. And then we go one of these. There, this is what auto trace gets you. So we're not going to be using auto trace. Altium is very expensive. I considered pirating it as I wanted to move my career towards building PCBs professionally, and I realized how expensive that would be to learn. And then I talked to guys who did PCBs professionally, and they said, don't do PCBs professionally. And so I decided to try to go for my PhD. And all of my EE PhD friends said, don't try to go for your EE PhD. So what the hell? Insular fucks. What goes here to here? Oh, right. This is on its own, and it goes out that way. If I did like... there to there. This one still needs to go to here, which is tough to do. That basically cuts it off, and I'll have to use like a via to go to the other side, huh? They're just trying to keep job security, yeah. What is the best way to do this? This one goes to the Night Realm, and then this one comes from there. So that's not really blocking. It's sort of the one that also goes all the way out to here that's annoying. And if I go out to the edge of the board and over, I'm still condemning... well, actually, no. If I do that, then this one has a little space right here for a via. I don't want to get too close to the edge of the board where the potentiometers are, which is going to be here and here. So that this one is clear. It's the other ones that I want to be careful about. Knock that in a notch, and let's come out from here. In N39, we can move down. Okay, here's the deal. All right, this is gonna get crazy. So like I said, when you play Satisfactory and games like that, it feels very much like building a PCB, and I don't think I've left that comment on a few streams, and I don't really think they understand me. Wait, but if I move that, then I got to move the other one. Although that'll get this whole complex a lot closer. And if N39 goes all the way around everybody, or if it goes up here, where's that one going? That one goes here. This one goes there. This could move up to here, and then it would be a more direct path with the chip moving down. That means that I don't have my capacitor on the right-hand channel. There's a little bit of overlap that I would really like to kind of eliminate in this. Eliminate. Do you plan to work with KiCad in the future? I would love to, and I would love to move all of my stuff over to Linux, but Fusion 360, the Autodesk people actually pay me in a subscription to this software. So I would like to learn KiCad. I don't really know much about KiCad. I cut my teeth on Fusion, and then Fusion Eagle back in the day was sort of the hobbyist program that you could get for an affordable price. And so that's what I learned on. So this is Fusion, or sorry, this is Eagle that's been rolled into Fusion 360. I know AutoCAD, I know Inventor, now I know Fusion 360 really well because that's just what I've been using. Fusion 360 allows me to make a circuit board and then do a beautiful 3D render of it, and then move that 3D render into other facets of CAD. So I can design 3D printed parts that will fit onto the circuit board, and I can do things like avoid ICs and weird little things like that. These are going to be kind of a problem, these clips. They're going to come pretty far in. Spent almost as much time doing placement as routing. Yeah, it's tough to optimize things, and especially because we have all this room on the board to run traces. Getting stuff placed in the right spots is going to be very important here. I may have to go to absolute minimum ratings, and I may have to go to 4 layers in order to get things to work on this board. Get a Mac Mini for Fusion 360 come October, since Windows 11 is way worse. I don't know, man. I may have to use 4 layers. It'll make it a $20 for 5 boards, but make it a $5 board for 4 layers. The amount of resistance and capacitance changed by trace length is so minimal that details like that firmly place things into the audio foolery category. Yeah, rounded traces, rounded or 90 degrees, doesn't matter. Rounded traces were kinder when we were using solvents in order to etch boards. Now it's like lasers and deposits and shit. So you're not really going to be dealing with like a solvent trap. Rounding the edges, in terms of what I'm doing, just looks good. That's all. Yeah, 45-degree notches and stuff it's totally fine. If you really get down to the nitty-gritty, if you're doing RF, then yeah, you can get into those kinds of details, but we're not doing RF. We're simply just not doing that. Left is all the way up there, so it makes more sense for that cap to be way over there, but then the left accoutrement is all the way down here. These are symmetrical, they're just getting fed from different pins on either side of where the chip is installed. Unless I move it 45 and have my feedback and power pins, like if I, not 45, but if I do that, then it can be a little bit more symmetrical. These don't benefit from going at a 45-degree angle because this is a mirrored chip. So it's got 3 blank pins in the middle, and then those 2 are the input, the positive input, and then we got the negative input, and then we've got power input for some reason put in the middle of this fucking thing to make it even worse. And then we have our output there, and then negative voltage. So they're 2 symmetrical amplifiers in this headphone chip. Yeah, unfortunately with the op amps and the way that they're laid out, the 45-degree angle thing didn't work out. I was fully willing to go into that. I was fully willing to do 45-degree angles on it, but it just didn't work out. It just didn't work out that way. I'm going to make sure that this thing is on 5, not 5.08. This is a 10 millimeter wide board. I want that to be right in the middle. Probably puts it off the grid. But you know, you hide the little grid alignment things underneath the chip. We're dealing with Eurorack, so we've got plus 12 and then minus 12 and ground. This is a two rack panel sized mixer module. So it's going to look this size. It's only a little bit larger than the connectors that are connecting it. And I'm trying to work with 2 layers at first. I'm obviously probably going to need to go to 4. I want to see if I can optimize signal paths and stuff to the point where if I can get away with 2 layers, it'll be eloquent. But yeah, we're using JLC. I've got their design rules in. I'm not at their maximum minimums. I'm not at the absolute minimums yet. And then we have, because of the way this is laid out, the SO16 only fits underneath a potentiometer. And I can't find anything more modern than SO because these are V2164 audio amplifiers, a voltage-controlled audio amplifier. That means that you need to take your audio into frequency domain, and then you can do all kinds of wacky mixering with it using voltage levels to control the VCAs. It is a stereo mixer, so we have 4 channels of input, left, right 1, left, right 2. We control left, right 1, and left, right 2 using 2 separate knobs that are a single potentiometer. So 1 voltage level getting sent to both of these. They didn't make them high Z, so I had to have an amplifier for the knob, which is crazy. Maybe I could make like a delay on the amplifier knob or something. I could put like a big capacitor in there that'll slowly change direction. I don't know, whatever. But because of that, I need to have 2 of these chips, which means that 2 of the under potentiometer locations are taken up. The way I've arranged this thing, there's room for amplifiers all over, that means that the final amplifier, I guess this is the final amplifier and this is the headphone amplifier. This is converting it back into, or no, that's the top of it. This is the bottom, sorry. At the bottom, I have my final amplifier, but then I've got one of the voltage controlled amplifiers, and then the final amplifier that's required. It's required in order to turn current back into voltage, which is kind of kind of an obnoxious thing of this to require. You have to have another op amp in here, and this is what inverts your signal. So having another amplifier, the headphone amplifier on the end, makes sure that our inputs are in phase with our outputs. So what it means is that my signal path is control, input, 4 channels, first stage of mixing, second stage of mixing, aka volume control, where I've actually doubled up the amplifiers because we have 4, we only need 2. Apparently that gives you more granulation or whatever, I don't know. And then we go into our initial output and then our final output, which is just crazy. What's going on here? Why do I need, oh yeah, so what that does is that allows us to, I can do a unity gain amplifier on that output, and so I can have a normal signal and an inverted signal, and I can give those directly to our final output, which is a differential. So we're creating a differential in the audio, and supposedly that'll make it less prone to noise and all that stuff. So I think we'll have maybe some hidden advantages of doing things properly. The only reason that I'm doing that, instead of just having it be a single-ended amplification stage, which it can do too, is that we have 2 extra amplifiers. I don't want to involve many different chips. I want to use a small pool of parts. And so with that quad amplifier, we've managed to have 3 amplifiers that aren't being used. 1 up here in the controllers, and then 2 down here. So why not just use those 2 to make a unity gain amplifier and make an inverted signal? Maybe that'll have an advantage, maybe not. Either way, it just means that I need to order fewer numbers of different parts. It keeps me from messing up. And so this is a TLO74 equivalent. It's kind of close. It's like a modern TLO74. TLO74 doesn't come in QFN. We need QFN because we have 10mm wide boards. It's so small. I can't put any more parts like this in there. So we did the whole breadboarding thing to the point where I used the same QFN on a breakout. And so this works. I didn't do the hardcore engineering like frequency stuff on it. When we get this board in and build it, and I can finally cry, we can do some more like frequency sweeps and stuff like that. We can categorize it a little better and see if what I done good, or if we need to sprinkle it with capacitors, which we absolutely cannot do. There's no room. There's just no space. I need to put some system caps up here because I think I'm foreseeing a little bit of a power supply draw issue. This is the same chip in a different package on a breakout board. There are some capacitors in the audio, mainly to deal with sudden draws of current. So, Audio Precision SYS 2722. I don't even know what the hell that is. I don't know what that is. I don't follow audio stuff that closely. Oh yeah, this is an old render, so this is sitting out in space. All right, so we tried a couple different layouts here, and I'm just trying to see if I need to like rearrange certain circuit elements in order to make this easier on us. Oh, I see, it's a tester. Yeah, the best I got is a little personally made frequency sweep and the teensy 4.0 hooked up to a bunch of I2S audio things. That's what this is. I didn't program a menu for this. Maybe one day I'll get back to it. And then all things considered, when I really get into the swing of designing PCBs, this is a PCB, or this is a Eurorack tester. I want to put all the Eurorack tester electronics onto a board this size. So this is all in Fusion 360. And now that I have the board size and the hole locations and the hardware locations, I can then go and design a PCB that will house all the electronics that'll run this thing. There's a lot of software that'll go into that to make this thing work. I don't know exactly how I'm going to do it. There's a lot of screen stuff that I got to learn, but it's got a VFD display, so it'll look really good. Stay away from playing punk rock music and you won't have so much of those deep bass notes to deal with sucking up all the available current. I will make no promises about what is played. I know this stuff can do audio, like just directly normal audio coming out of it, and we'll definitely want to test a variety of stuff in there. Yeah, that's like what my friend was telling me. He wants to play trance music from the early 2000s, and he was concerned about the sudden current draw from the trance music from the early 2000s. And I'm like, bro, that era of techno had the same beat from the beginning to the end of the song, because that's how they mixed them all together. The best you'll get is at a big crescendo, and it'll suddenly go boom, boom, boom at the end. But that's still using up just about as much energy as the beginning. It doesn't vary that much in that kind of music. I don't know. He's a little bit too detail-oriented for his own good. Speaking of details, boy howdy are we struggling with this stuff. How much vertical space? What do you mean on the back with the SMT? We have snuck parts underneath our potentiometers even. We got decoupling capacitors, and then we got these guys that are eerily close. This 3D model, basically what I'm going to need to do is take these pins and flatten them a little flatter against there, and possibly have them go just a little bit inwards in order to fit into the pins. We've really min-maxed this thing. Solved where to put the big capsules having large TH caps flying over the PCB. That would be insane. I don't know if I'm going to do that. I think we're just going to have to like triple up on surface mount caps. The decoupling caps are going to be under the potentiometers. We tested to make sure that that could be a reality. There's also the potential under these Thonky Kongs to maybe sneak a component in, but I'm not going to do that. That'll create these weird spaces that you can't get to. These resistors that I've put on the outside here, these are for adjusting the potentiometer's range, because it has to go from negative 600 millivolts to 3.0 volts, I think. How about tombstoning all the resistors? Oh, God. And slapping another board on top to join them together. If I did have to join them together, I have 3D models of my headers. We can fit headers on this as long as I cut the leads so that they don't poke out. Dead bug the whole thing, build it sideways. I actually have seen ICs used to bridge PCBs. It is the most cursed thing. What I was thinking is another version of the board, right, where it's double wide, but it's cut in the middle. And so you could crack the two boards apart, and there would also be headers on both sides. So you could install the headers, crack it in half, and then plug the headers into each other to make this mixer, the 2 HP version. But the 4 HP version would have controls on it and maybe utilize this extra control as something like a fader between right RL1 and RL2. So you'd have it fade back and forth between them. Even better if it's a 555. I think you could get away with that with something that's built like this amplifier, where it's two completely separate R&Ls. So if you only power one of them, you power and V and ground on one side and on the other. I don't know. Structural 5. That's a load-bearing 555. Flying buttresses of 7805s. I've seen some very cursed stuff in my day. Doing all the IC's tombstone would be, or all the chips tombstone and having it bridged to, that's like a Peltier. It would look like one of these mofos. That's what a Peltier is, a bunch of silicon diodes that actually facilitate the flow of heat from one plate to another plate. And so they have, basically the design of these things is two ceramic circuits that have all the pads on them wired up so that you put, and just an inordinate amount, it's just a sinful amount of power into this circuit, and it'll pump heat from one end to the other. You can run a trace between the pads. Yeah, between the pads, we're going to be using that a lot in this design. I was hoping that maybe I could get it down to fitting 2 traces if we really went with the minimum, but it seems like the minimum is rather large in comparison to what I was doing with the flexi-pcb. And I wanted to keep the traces a little bit big so that I could actually see what was going on. But my fridge is one of those little desktop fridge. They use a lot of power and they're not very good at their job compared to something with, you know, state change. I work in millimeter instead of mil. It's, I don't know, to me it's less confusing. I know a lot of the old guard of circuit stuff, they like working in mil. But I translated over. So I think it's 3 mil is what they were talking about. So technically, I could go down to 0.1 on that. And we've got the minimum via size in there already. 0.1 is what I use for the flexi. It doesn't look all that different from the other trace, does it? Oh, it's gone back to 0.2. What the hell? Why are you going back to 0.2? It might be something that I put in the settings. Yeah, it keeps defaulting me back to 0.2 millimeter. I'll bet you 0.15 will stick. Going back to 0.2. Yeah, that's definitely in the design rules that I need to change it. Well, that's stuck. That's much smaller. But then it comes back in. Yeah. All I get is a done dialog. Yeah, okay, so it's definitely in the design rules. So let's go to the design rules. Let's go to rules, edit the rules. Wire, wire, wire pad, wire via, board outline, blah, 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 blah. Huh, weird. Okay, so something's fucky with this. Design gonna 0.1. And then it just goes to point. Something is messing it up. Copper width, is that what it was? Via clearance, 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 clearance. Copper restrict, no. Board outline. Via solder mask drill, component exclude. Unconnected lines, copper width. Oh, there we go. Yeah. So 0.1 is the minimum. We're gonna have to brush up against the minimums here. What was our drill size again? It was 3.5, I think was actually the minimum. We need to make sure that's in there. Preferred, we're gonna put as 0.1. Okay, so then now it should stick. The insidious little things that it does, it really would be nice if it told you, like design rule, interference, put a little star by it or something. Man, those are tiny. That is just obscene. I mean, the fact that they're capable of making this in the first place, this size, is crazy to me. I got like miles of room between these. Oh, I see. It's not snapping. Hold on. You need to make it snap or it's going to have a microscopic air wire inside of it and then it'll yell at you. Go, you didn't do this right. Yeah, the reliability. I haven't run into problems with this yet, but all my designs are giant, like cave drawings. They're like big stick figures. So this is getting into the slightly more elegant land of crazy traces. The whole circuit is a fusible link. Well, anything is if you try hard enough, for sure. I wonder though if I should. It would be really no. It's everything's too close for me to use those. Never mind. I keep trying to convince myself that I need to use the 45-degree angle smooth traces to match my smooth brain. And this I can actually boop, boop, boop. We can align these again, and that gives me enough room to go from here. Ooh, that's going to be a rough one. This is where we use this. Nope. I didn't actually hit it. This is probably because I didn't put it on the 5.08 grid, that it has this little move to the side. The pin pitch I think is compatible with 1.27, but that's okay because it'll just go into that a little weirdly. I don't think I have the capability on Fusion to do teardrops on the apparently when you're dealing with higher frequencies and stuff, having the trace fan outward in a teardrop shape is really good to do, but yeah, Fusion has auto route. I don't like auto route. I don't really like auto route. Takes away all of my agency. I prefer to design it myself. I would like these to be larger traces, and I can kind of get away with it. Unfortunately, I can't get around this. See, yeah, Altium escapes me, but I know that their auto router is like the best. Are they still the best? Probably not. I don't know. I would love to do a circuit board where I use Topor router to go as the crow flies. Use it for layer complexity. Last time I used the Eagle auto router. Blah, blah, blah. Last time I used it, it gave me a bunch of options for the board, and I didn't like them at all. But it was in kind of a more rudimentary state from what it is today. Ah, almost got it. I see. You don't use it for the final design work. You just use it to scope trace densities and stuff. That's interesting. Oh, yeah. Jeez. 6,000 components, took design layout place 3 weeks, and after I did the first 20%. Oh, my God. That's incredible. My PCB design experience has mostly been hobby projects like this. I'm not like min-maxing at the absolute edge of what's possible for humanity to design. Oh, what happened to you? I don't like it, but I'm gonna leave it. 32 channel power over Ethernet cable modem. Oh my God, that's intense. See, once I do the little thin layout, I can see that, like, I could make a lot of these traces a lot larger than what they are right now. I'm not really using a whole lot of techniques that require these traces to be absolutely minimal. This is symmetrical, by the way, so I'm just doing this side. This one I'll have to take the top layer and come all the way down across the chip and then drop down over here. But right now I'm just trying to make it a one-layer PCB as best I can, as bestos I can. This is an unfortunate one. I could maybe get around by making it vertical and going down through the top, but maybe that's not really such a great idea. Now, the other way that I could do this from there, or I can put this closer to its destination, which is another, it doesn't have room over there. There's no room for something like that. This is the input to the negative feedback, and I have to assume that they made this in some way, shape, or form where you can arrange these things more easily. If I move this up, this is the debate. If I move this up here, and this goes through the middle of it to get to there, that doesn't give me any advantage, does it? Oh yeah, sorry, I pepper the dumb jokes into everything. It's just the way I deal with language. I don't know. Like, okay, we're smarter than this. I'm not this dumb. Believe me. Some of the requirements are weird because we can't get into the chips from the other side. But if I move, well, this is its own little loop. That's fine. But we want to get this signal out. And so if I take this on top, that's out. And I go, hold on, I'm thinking. 2 traces under the chip is really kind of cursed. I could do it, and then I could have N39 would be on this side, and then I could go up and over. Ah, that doesn't really work. No. Moving this one in or out, and we can't go under the chip because of the heat sink. Yeah, we're just going to have to via. It's just going to need a via. There's no other way around it. There really is no other way around it. That's so close to the chip. I really don't like it, but it's all I can do. And then let's actually just go directly from here, and I'll take this and go under and around. I'm switching to my layout now. Placement's the most fun part. 200-ish parts, 4x4x2. Jeez, QFN is the smallest. That's crazy. Quad flat, no leads, yeah, are about what we can handle in the hobbies. I really don't want to deal with BGAs. You can, I mean, you can do all kinds of fun stuff with BGAs, but it's oh boy, it's a whole nother set of just brain veins. Yeah, have fun. Hey, thanks for shooting the shit with me for a little bit while I try to figure this stuff out. Over the weekend, I did intense layout, and it was very much like just ADHD hyperfocus. Preferably, I could get this out of there. Oh no, that's right, I can't. Move that back. That's got to live there, because this has got to go there. That's right. Now I remember. That one goes there. Power goes there. What are we going to do about all this? That one I can sneak over, and then this one has to do a short via, which I don't really like. Hardest thing I've ever laid out myself was a big mess of through-hole dip memory. That sounds like a, yeah, memory stuff. Well, this is probably the most dense and confusing thing that I've laid out so far. Is this just a simple little mixer circuit that ballooned into this complicated thing, and I keep saying in the hopes that somebody is going to challenge me, but I don't think anybody understands this enough or has seen or has dealt with this stuff on the level that I am. That this is the minimum complexity of the circuit that I can build. I could do something that's inherent that controls voltages with op amps, and it could be a much smaller mixing circuit, because mixing with op amps, you literally just throw everything onto a voltage line. That's all it is. But the problem with that is that you then can't complicatedly, you can't have complex control over the gains of the amplifiers unless you use a dual pot. And I don't want a pot to have direct control over the gain, because it gets scratchy sometimes when the pot starts to wear away. So I have a buffer amplifier in there that'll provide a voltage level to 2 different voltage controlled mixers. So that's the sort of way that we've done this. And I don't know, maybe there's a better way. There's probably a better way. Maybe I could find an ASIC that does, or I bring everything into the digital world. If I put in an I2S audio driver that's 2 channels, and I have one, I've got them sitting right over here. If I put one of these and something like an RP2040 on it, I know, it's kind of boring. I like keeping it analog, but, you know, whatever. I'm doing it this way. It'll be fine. It'll be fun. It'll be fun. Fun. Remember, fun. It'll be fun. What time do we got over here? Oh, we're doing well. 32 by 16K by 1 DRAM chips to the board within the S100 footprint of 64K of addressable RAM. Jeez. Yeah, it is this. Well, that's Eurorack. That's what it's for. So I'm gonna have no choice but to go to V+ with a VIA.
And it just seems like there are no options for getting this to hop over this. This is an NC, but I can't get to it around this way. Did a digital module and a 2 HP in the same single board format recently. It was fun to lay out. Use one of those new AT Tinies. Oh, are there new AT Tinies? We've used AT Tinies before to do like an RC car motor controller circuit. That was another piece of design that sort of thrust into the 21st century, and I had to use some very minimal trace layout stuff with that. I have it in my boards, my bin full of boards that I've designed. I can't find it. The best PCB that I've ever laid out was an absolute banger of a circuit. Oh, here it is. Absolute banger of a circuit because it was literally just a button. And I made it for Tom Thinks. If you guys don't know, you guys got to check out Tom Thinks' Twitch channel where he does live animation. And if you don't know what that means, you should go watch. Because it'll be pretty immediately apparent what he's doing over there. But he basically controls puppeted characters that are Adobe Flash animations. It's pretty cool. I put my own logo next to it. This is a housing. It's his toot button from 21821. And this is Tom's font, so I can only use it with Tom's stuff. I put his little animated avatar picture there. It's basically headphone plug, rubber button, and then in Fusion we designed an enclosure around it, and the mechanics of the enclosure so that it just had one little stainless steel rod, and then it was just a big thing that you press down, and it has toot written on it just for grip. That was one of my best because it was such a home run to just make a little button board, that's all, and put a housing around it. But the RC car was when I really went into like, what min-max capabilities do we have from a place like Seed Studio? Or actually, no, this is somebody else. I think they did their After Dark service in order to make this. But this is an AT Tiny 85 and a very special MOSFET, like motor, or FET based, I don't know, it was a motor controller. I couldn't actually get it to fully turn on the motor in forward or backwards. I don't know what the hell is going on there. I didn't kick off my transistors properly, but these are brutal MOSFETs. They're crazy powerful. So this is sort of DOS micro components going in here, and then the motor controller with the AT Tiny on the back, all the stuff around it. That was fun. We got that together pretty well. We used curve traces, but yeah, now we're doing modular synthesizer stuff. You needed 6 by the time it was done. Damn. And then there are different spacings for the inner layers that I have to worry about. I installed Easy EDA, went through the process of getting their free license key. So let's start. Hey, that should be fun. Isn't there a threshold before the motor starts to turn, and even beyond that, how the motor starts to spin if it's under load? It's called hysteresis. That's called hysteresis, when the magnets can no longer press the motor. What was happening is the MOSFET was not fully switching over, and I don't know what was causing that. So the motor was turning, it just wasn't turning fast enough, and I was trying to make a RC car motor controller, so... All right, let's see here. So whatever I do to the right side, I'm doing the left side, except for that the capacitor travels, which is fine. We can probably take this to an upper layer and then bring it back over here, but I don't know, you seem to be fixated on getting the motor going. It was more getting it going at max speed. It was still spinning, it just wasn't going max speed. So let's see. That one doesn't really move. That one stays fixed there. I could bump it over 1, but that doesn't really get us anywhere with this. The only problem is I need to get around this. Comically, I could go around and then... Whoa, no, that's not good. Can't get into there. This signal here blocks it directly. If I take this one up and over, I guess I could do it that way. It seems a little circuitous, and I want to minimize these paths, but if I'm left with no other choice, you've left me with no other choice. I have to go around. No, you can't do that. The signal's too long. I have to. So if this goes, wait, no, that doesn't work. Yeah, wait a minute. Okay. So this goes out to all my DJs. But making moves out on the dance floor. Go out like that. And then Craig David, take those down one so there's not a hole in the middle of it. There you go, messing up my signals again. There it goes. Like that. And then this one, coming in hot, goes right there. Oh no, I clicked, weirdly. Every time I hit Control Z, the program lags significantly. I don't know what mechanism is behind the Control C-ing, but it'd be nice if they could work that out a little bit. Okay, these are different positions, so we need to establish what this column is. .146. Wait, no, that's the vertical position. 4684. Three. Wait a minute. How are those so different? Oh, because this part is uneven, I think. Well, if I turn this to 4.6, it's going to move it over a millimeter, which is crazy because these are lined up almost. That's really annoying. The part is asymmetrical just a little bit. So we'll just take this up here and I'll scooch it over a tick. Oh, it doesn't like that because it has traces. What? Where else? Oh, there's still a little piece in there. Too close to the edge. Those need to be here. I think that's got it. So I'm going up here to this one. This one can reconnect the way that it wants to. And then this has to wiggle its way. I'm still tracing there. I hate doing that with these. Maybe we can use the 45-degree ones here. That. And we're using this over here. And then go back to curve traces so I can just round that bend. Does that look okay? I guess that looks all right. As long as those aren't different radiuses. They are. Wait a minute. This program is not helping me be clean. Purge me of my sins. Make me clean once again. Ah! Oh, we're in the wrong snap, that's why. Oh my god, Control Z it all. Put it all back. Put it all back, Control Z. There we go. I'll have to just deal with it like that because the thing is so weird. What's up, Madame? I don't like that, but I don't think I have much of a choice over that, do I? So that's going to be mirrored on the other side, and it looks like I can probably make this a full 0.2. It may need a little bit of wiggling to get it into the right spots so that everybody's properly avoiding each other. But again, you know, I'm spending all this time very carefully rearranging things and making sure that my traces are laid out flat and simple so that our signal path can be perfect in this way. You know, we were told that we wouldn't be able to do this within the number of layers that we're doing it, and it turns out we are. Yeah, let me redo this one, but make it in the center of those chips, and then we'll see if we can bump it up to 0.2. So I'm going to take that, going to go to this. I'm not going to make it that new size yet. We'll see the trick about doing that in just a second. We'll make a nice soft bend. It needs to be a larger radius so that it doesn't bunch up when we make it full size. All right, and so now what I'm going to do is, instead of, you know, right-clicking everything and changing the number, I can use the change tool. So I can do, where are we? Board shape, layers, blah, 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 rework. No, not rework, modify. Yeah, modify, change. It's the C key. Change, and now we can go to width all the way down here. This is every option of everything you could possibly change of any circuit type component. It's one of these things that Eagle had that is a little bit weird and confusing for AutoCAD. It doesn't quite, I don't know, mesh. But if you want to change a lot of stuff on your design, you use this tool and you can click, 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 and just change everything. So we're going to go to 0.2 millimeters with these. And all I need to do is boop, 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 boop. That's it. We're just making them big. And now they're just big boisterous traces that we can easily path with our human being eyes. I wonder if I want to do, we tried 45-degree traces up here. I wonder if I could actually make that work a little better instead of being, because this is kind of clunky. I'd rather it be like this, but that requires a lot of space. I want to try it. And then up here as well, without making it look like it's a direct 45-degree path out of here, because those can fit just fine. I can make that look good. So we'll bump you. This is already bumped to 0.2. I mean, exiting the corner is a little weird. Oh, and then I need to go to alt spacing. There we go. Alt spacing gives me a couple more options. This is weird and fluid. Nope. I mean, I'm not mad at that. It's just a little strange. Oh, we didn't make this one big. Change tool C. And it brings up this huge dialog. 0.2. A lot of little things to click in here to make this larger. Actually, that just doesn't work in 0.2, so I need to rework that. Easy enough. 0.2 may be a little bit meaty for our purposes here. Back to this one. Doink, and then doink. No. Doink to doink. This one has sort of worked its way around that. Don't want that in there. Damn it. The keep out area on the capacitor is very annoying. I need to alter that part. Okay, supposedly that'll become, yeah, that just became one big line segment. So if they're lined up, they'll actually combine nowadays, which is new for the software, but it's neat. I could run some angles over here to try to get them a little closer to one another. I'm going to leave that alone, though. And then over here, we need to have some kind of a smooth path. That's a little awkward. That's a little awkward. And yeah, it could just go diagonally. That just seems a little weird to me. Huh, I guess it'll just go diagonal. That's so strange. I guess it's all right. I suppose so. My standards are lowering in front of your very eyes. Okay. So now, taking that one side into consideration, we can now do the other side. Should these be much smoother? Nah. I actually, you want to avoid this kind of trace going into the end of one of these because it'll make like a pinch point that might be hard for it to etch. Hard to get etched. I'm going to have to go to my other Fusion 360 and do the modifications that we did today to the preferences. Basically making the snap into a much smaller snap. And the problem with that is that now I need to make sure that I get the green X whenever I connect one of these traces to a pad so that it counts as connected and there's no air wire inside of it. You can ignore the design rules. You can tell it to ignore the air wires, the air wire warnings, but it's you know, if you do those little things like the connection stuff, then you don't have to worry too much about, you don't have to like deal with the design rule violation. And this kind, oh, that's not where it's going. Oh, because we need to rearrange these. You go here, and I need to see where I'm aligning them, so let's go down to that. There. I don't know which one. Yeah, this is correct. And then this one's that, and then left. And then technically, do it like this, doesn't really matter. Because that'll have to come from the other layer. Okay. So I'm wondering if laying this out on its side would have been a better idea. But then we've got these pins that are kind of just in the way. So we've got such space restriction that it's making the layout kind of strange. It would be nicer if we had something the size of like a mutable instruments board where we've got all the real estate in the world. And so we could lay things out a little bit more logically. You'd be able to see a flow from one side to the other. This thing hurts to pick up too because it's got through-hole devices on it. Ow. Hurting my fingers on these things. Okay, so let's see. Left audio is coming in there. This one is doing its little dance. And then the signal paths aren't going to be totally optimized. But that's okay. And I want to come up from this one with a little one of these guys. What does that look like? I just want it to look the same all the way up to here, so that should move over a little bit. Wait, that doesn't look right. That one should be centered. This one should go to the left. Have that much space on it. So why is that? Oh, do these need to be moved outwards a little bit? Looks symmetrical. So 0, 0 is here. This one is at 1143 and then 7. So 7847 should be the same as this one, 7847. It's not going to be, but if I do that, then they're even. Yeah, 7, 8, 4, 7 on the grid. On the grid, those two are even, and so this one over here is at 8.146 minus 5. So 3.146. $4.8. That was the wrong one. Eight, 7, 6, 5, 4, 3. Yeah, 3.146 should be from 0. But it's at 1. This ain't right. Wait a minute. That seems way wrong, sort of. Oh, is it because the 0 point should be in the center of the resistor? So this is a 5 by 5. This one, how does that work? Running into all kinds of weirdness now. Yeah, because that's too close. I'm going to Control Z because I want that on the grid. It seems to be like it's there. So we're dealing with a 10 millimeter board. So half of the distance is 5. So if you take 8.146 and you subtract 5, aren't you moving it? That doesn't seem right. That doesn't seem right. You do 10 minus? What do you do? How do you mirror that? My ability to deal with numbers is limited. Well, I may need to do some work in order to align stuff a little better. I wish there were lighter align tools. I could give it distances that things should be apart, but that's going to be a lot of work to derive those numbers. And this trace was like kind of far away, and yet that one's super close. But now this one's even closer, and that one's even closer, paradoxically. They're both too close. There should be room for one trace inside here. So it does seem like these need to be moved to the right. I'll do the other direction of select, and that selects everything that it touches. I just bump it out like that. It seems like it needs 2 bumps in order to fit properly, but this is getting too close to the edge. And that trace had plenty of room to breathe. That's too close compared to over there. It seems like it was in a good spot. Is this over to the side? No, this is exactly the center. What the I'm going crazy. I'll try to route this, just see where it goes. So that came out of the corner. That's not coming out of it. Yeah, see, and then that's squished. It doesn't fit. Using this, there we go. Does that look symmetrical? It looks symmetrical. This is kind of hard pressed over here. Maybe they're flipped, and so the grid is a little different because the distance from one side of the resistor to the other side of the resistor is asymmetrical. That may be the case. I think yeah, look at that. That cursor's off by a little bit. I think there's a little asymmetry to these parts, and it's going to affect how things go together. But I can move these at very small distances if I need to. So highlight these and then hit the alt text, the alt distance, and then I can kind of sneak them over. Just, oh, no, no. That interferes. Just move it out just a little bit. Of course, the height of all of them is different too. Got to do that. Still too high on the right side bank. All right. That seems a little bit more even. It's not quite there yet. Oh no, my board edge. No, right clicked. What the hell just happened there? Oh yeah, that was living outside of the thing anyway. Okay. Like that. And then this one a little shorter. Nope, it immediately blew up. Why do you blow up? No, it looks better before. Okay, so like that. Does that look symmetrical? Insofar as I refuse to calculate anything, so everything's off by just a tiny little bit, but that'll all come out in the wash. I really don't want to do this down to calculations. This is still completely, this is messing with me. Where's this located? Hello? .953. Make that into 5. It scooches it over just a tiny bit. That doesn't look centered. Ugh, weird. The geometry of this stuff is very annoying. See, like this trace is coming in and it's not, it doesn't have room to make the bend, whereas this one comes in almost at center. But if I center this a little bit more, this won't have room to do a full bend either. So it's got to be the distance down here. That goes to the center of the part. That goes to the center of the part. That's a certain distance away from the edge. This is a certain distance away from the edge. Looks like, no, it looks like the same distance. I don't understand. I just don't get it. Okay, so this is a slightly different distance here. Maybe I can work with this. I can go. I could probably use the mirror tool to help with this, but curves, these curves, other curves, always different curves. Alt, drag it out a little bit. That looks symmetrical enough. This one could maybe be a little bit smoother. Smooth this one out too, just a little. All right, and then I guess now there's room back here. We're still not quite on the center there, but I guess it's good enough. I can't split hairs that much. Okay. Moderately, somewhat symmetrical, a little bit. Bring this in here, flip it around. Get it just about centered. Good, good, good. Yeah, that actually looks pretty symmetrical to me. All right, and then onto this. Go like here. No, don't move the chip. That ruins everything. Control Z. Jeez. I'm sure I could make this mathematically perfect, but I really do kind of have to just settle for good enough at a certain point. And then I guess we're going to be going out here, like that, going into here. And then if it'll allow me, nope, it will not allow me to do this. Because I guess what I'll need to do is rip up the top. I did it in the wrong direction. There's a certain direction to do it with these funky traces that I like to draw, where you got to start from a certain point in the circuit. What is it doing there? Do you not? Oh my God, it hates me. Okay, that just made me alt-tab. Where are you going from? Down here? What the hell is that all about? What does it think it's doing? It thinks it's doing this one? No. Shouldn't. That's gonna think there's like an a microscopic air wire in there. You are the trace that I wish to put here. Are you kidding me? N49. Yeah, that's definitely the one that I wanted. Definitely you. You're definitely the one that I wanted to route. That's why I clicked here. All the way over here. That's why I clicked here. Yeah, see, it won't let me do that. All right, so maybe I can just connect to it from up here. It's frustrating because the program doesn't really know that I want to do this fancy type of junction where I've got it filled in. I don't want to have the pointed, little point in there and stuff. So you got to kind of work within the foibles of the software, work within all the weirdness that the software introduces. That's looking pretty good. We can just take left here, and we can move it over to its own little via. Hopefully not stress out all of this stuff. Now, it won't let me put a via there. So we got to find a spot for a via to take left audio up to the top. And I guess it can probably just go inside of this, can it? It really wants me to make it separate. Okay, it looks like it'll allow me to put it out here. So I'm going to put it out there, and we're going to go directly up and over to left. Ta-da! Wait. Unroute that. Okay, let's route that last leg so there's no air wire. Whatever. Good enough. As long as it's under the pad, it's not going to be something that anybody sees and then the software recognizes it as what it is. Yeah, so that would be the headphone amplifier portion. There's a lot to go, and I haven't done power yet because I'm gonna. What the fuck just happened here? What happened here? What occurred? Why did that undo? There. Why did that undo? I must have hit Control Z too many times. Okay, so because we're on an FR4 board, we're on an actual fiberglass PCB, we don't have to worry about, traces can be on top of one another. That may kind of hurt signal integrity at some juncture, but it's not really going to make much of an effect here at audio frequencies. So running these two traces in the same direction for a little while, not that big of a deal. That you can capacitively couple things by running them along the same paths, but that's not really, we don't have to worry about that at this scale. So far, so good. We've got kind of a beautiful symmetry going on here, which is all going to be violated with the next stage, which is the offset op amp. That's going to ruin our day. I already feel sick to my stomach looking at it. But we're at about closing time here. The sun's already gone down. It looks like the window in the background is dark, which means we're going to have a dark walk with a puppy. I got to go walk my dog. I will catch you guys next time we stream, which is going to be Thursday. We'll see if we're still doing circuit board design. I'm going to try to do those last couple things to the other board. We made a lot of progress today. It may not look like it, but getting things in sort of a virtually correct spot is a huge amount of work. It takes almost as much time as putting the traces down. So this design is going to slowly walk. I'm walking from the end to the beginning. We put the headphone amplifier together, which is this nice symmetrical, kind of a cool looking pattern there. We then need to go back and back and back and just get the different facets of this design done. I think I may jump from like amplifier stage to amplifier stage to amplifier stage, and that'll get those in a good place, and then we can do all the big connection stuff. Glad I caught a stream. Have a good one. Hey, thanks, Beatus. Yeah, I appreciate you guys being here and walking through this with me. You guys had a lot of comments that kind of saved me some time, and I hope you guys learned a little bit about layout and stuff. This isn't sponsored ad. I'll do another one of those at some point. I probably already got so many of them, but oh, I missed this one. Sorry. Max speed, how do you determine that? How do you go by specs and then use the second thing? So how did you measure it? We did nothing of that sort. for trace layouts and stuff, max speed on a line, that's going to require a little bit of electrical theory to kind of explain. But on our level, when we're building a circuit board like this, we're not trying to hit maximums. We're just doing audio frequencies. And so if we have enough copper there, everything should be fine, as long as the traces aren't crossing too much distance. It doesn't make sense to kind of get into all the Maxwell equations and stuff like that would be required to know. If I'm doing high-speed digital stuff, I don't really deal with that kind of thing. Do we need to meander traces in order to make everything the same resistance so everybody gets up to voltage at the same time? Bruh. I don't know, man. But there are, boy howdy, are there a lot of people making YouTube videos about circuit design and stuff like that. So it's probably within means to just Google or look for a video on YouTube that'll explain what another engineer might think when they're designing something like an RF board and you're dealing with those high frequencies and what kind of foibles you have around that. I would be interested in learning about that. I've got a couple creators that I follow that do things similar to that. They don't pull any punches when it comes to explaining how a circuit works, but I have not absorbed a lot of knowledge from them. But anyway, down here on Earth, down from Mount Vesuvius, among the mortals, we don't need to concern ourselves too much with that. And most of our design considerations are, does it look good? Does it communicate what the circuit's doing to the user? Those are kind of the facets that I like to hit. Those are the points that I like to hit mostly. Okay, so I didn't do the end card yet. I can do the end card. I can do this. I can do it. I can do it. I can do it. The next stream is Thursday, which is going to be the 9th. And so I just need to hop into the admin Discord. Secret, super secret mod channel. Now it's just the admin channel. It's just where I cut and paste the command so that you guys don't have to see behind, how the sausage is made. January 9th, we will be back. And yeah, same bat time, same bat channel, all that stuff. I need to let my voice rest for a day too, because it's feeling a little rough. That acid hurts your vocal cords. So yeah, here's the end card. And I will see you guys in 1 day, 19 hours, 18 minutes, and 30 seconds. I'm going to leave this up for just a second, just so you can, if anybody's sitting there with a notepad, www.https://discord.gg/SEHQ, kind of mess it up. I'm going to make that look more like a Q, capital W, so it's got to be huge, big 9, capital 9, and then Q. Okay, I'm going to go put that into a browser.